Hello there and welcome to Life Beyond Seen, where curiosity slows down, the world gets a little quieter, and even the wildest places on Earth can be explored from somewhere warm, safe and comfortable. Tonight, we are heading far south, down past the busy ports, the familiar coastlines, the green edges of the map, and into a stretch of ocean that has made sailors nervous for centuries. Our journey tonight is across the Drake Passage, a body of water with a very simple job and a very dramatic way of doing it. It sits between the southern tip of South America and the cold reach of Antarctica, connecting great oceans, carrying powerful currents, catching some of the strongest winds on the planet, and reminding anyone who crosses it that the sea does not always care about human schedules. It is often called one of the most dangerous waters on Earth, and for once, that is not just travel brochure exaggeration. The Drake Passage has a reputation earned by rolling swells, sudden storms, long crossings, and that famous old feeling that the floor beneath you is not as committed to staying level as you hoped. For some travellers, the crossing is rough enough to become a personal legend. For others, it can be strangely calm, almost polite, as if the ocean has decided to behave for a day or two. And that is part of what makes it so interesting. It is not only dangerous because it is violent, it is dangerous because it is changeable. Before we move farther into the cold water and the long weather systems of the far south, I would love to know where you are listening from tonight. Are you somewhere near the sea, where wind moves against windows and waves are not just an idea? Or are you far inland, with the ocean only a memory from holidays, maps or films? And if you were standing at the rail of a ship bound for Antarctica, watching the last land of South America fade behind you, do you think you would feel excited, nervous, curious, or already deeply focused on finding the nearest packet of seasickness tablets? It is an understandable concern. The Drake Passage is not famous for being gentle with stomachs. It has given the world the cheerful phrase, the Drake Shake, which sounds like something you might order at a seaside cafe, but is more likely to involve gripping a handrail and reconsidering your breakfast. At the same time, there is also the Drake Lake, the calmer version of the crossing. When the water settles, the ship moves with a softer roll, and passengers begin to suspect they have outsmarted one of the most feared sea routes on Earth. The ocean, of course, may simply be letting them think that. If you find this kind of slow journey into science, geography, history, and the stranger corners of our planet soothing, I would be ever so grateful if you gave the video a like and maybe subscribed. It helps this quiet little place reach other people who might enjoy learning about the world without being shouted at by it. And tonight, since we are speaking about rough seas, hidden currents, old sailing routes, and waves that can make even experienced travellers pause, it feels only fair that the telling should stay calm. The subject may be restless, but we do not have to be. So, get comfortable. Let your shoulders drop a little. Let the room around you settle into its own evening rhythm. There is no need to hurry across this water. We're not on a strict expedition timetable. No one is asking you to lash down equipment, check the barometer, or look brave in waterproof trousers. We can take the crossing slowly, one idea at a time, from the warmth of wherever you are. To understand the Drake Passage, it helps to begin with its location, because this is not just any patch of ocean. It is a gap between continents. To the north is Cape Horn, near the southern end of South America, a place that has long stood in the imagination of sailors as a hard, cold edge of the known world. To the south are the South Shetland Islands, and beyond them the Antarctic Peninsula, that long finger of land reaching northward from the frozen continent. Between them lies open water, roughly 600 miles or about 1,000 kilometres across. That may sound wide enough to give a ship plenty of room, and in one sense it does. But in ocean terms it is also a narrow gate through which huge forces must pass. The Drake Passage is where the Atlantic, Pacific and Southern Ocean systems meet and mix. That alone would make it lively. But the real trouble begins with the geography of the Southern Ocean itself. Around Antarctica, there's no large wall of land blocking the wind and water. In the northern hemisphere, continents interrupt the oceans. They break up currents, disturb wind belts, and give weather systems something to run into. Around Antarctica, the ocean has far more freedom. Wind can move around the planet in a great ring. Water can circle the continent. Storms can build over long distances. And when all of that moving air and moving water reaches the Drake Passage, it does not politely form a queue. The sea there has room to gather strength. This is one reason the waves can become so large. Wind blowing across open water transfers energy into the surface. The longer that wind blows, and the farther it travels without interruption, the more the sea can build. Sailors call that distance the fetch. In the Southern Ocean, the fetch can be enormous. There are not many convenient continents standing in the way saying, "That will be quite enough now." So the waves have time and space to grow, and by the time they arrive in the Drake Passage, they may be long, heavy, and stubborn. Then there is the current. The Antarctic Circumpolar Current flows around Antarctica from west to east. It is the largest ocean current system on Earth, and it carries water around the planet in a continuous belt. It links the major ocean basins and helps move heat, salt, nutrients, and cold water through the global ocean system. This current is one of the main reasons Antarctica is so isolated. It helps keep warmer waters from easily reaching the continent, which matters not only for ships and wildlife, but for the whole climate system. A crossing of the Drake Passage is not simply a journey over water, it is a crossing over part of the engine room of the planet. That may sound grand, but on board a ship it can feel much more immediate. The planet's engine room is less impressive when a cupboard door has flown open, someone's coffee has made an ambitious attempt to leave its cup, and half the dining room is walking with the careful focus of people pretending this is all perfectly normal. The Drake Passage is one of those places where large planetary systems become personal very quickly. A current that looks elegant on a map becomes a slow roll beneath your feet. A wind belt that sounds interesting in a textbook becomes a noise against the windows at night. A swell forecast becomes the reason you suddenly understand why ships have railings in so many places. And yet, people still cross it. Scientists cross it. Expedition crews cross it. Tourists cross it on their way to Antarctica, often after years of dreaming about icebergs, penguins, whales, and the rare feeling of standing near the bottom of the world. For many, the Drake Passage is not an inconvenience. It is part of the experience. It is the price of arrival. There is something about crossing those waters by ship that makes Antarctica feel properly remote. You do not simply appear there, you travel through a boundary. That boundary has a long history. Long before modern expedition vessels, satellite forecasts, stabilizers, radios and heated cabins, the waters near Cape Horn were feared by sailors trying to move between the Atlantic and Pacific Oceans. Before the Panama Canal, ships rounding the southern end of South America had to face some of the most difficult sailing conditions in the world. Cold, wind, poor visibility, huge seas, and little room for error made the region dangerous in a very practical way. A mistake could mean wreckage. A storm could mean death. A delay could mean hunger, damage, or weeks of miserable progress. It is easy, from a dry room with a steady floor, to make old sea voyages sound adventurous in a tidy sort of way. A wooden ship, a brave crew, a map with blank spaces, perhaps someone with an impressive beard staring at the horizon. But the reality was often wet, cold, exhausting, and frightening. Sailors faced long watches, soaked clothing, icy wind, heavy rigging, and waves that could break over the deck with the force of moving walls. Cape Horn and the seas around it became symbols of endurance because they demanded endurance. There was nothing decorative about that reputation. The Drake Passage also has another kind of power, one that's quieter but no less important. Beneath those rough waters is a living system. The same currents and mixing that make the passage difficult for ships help bring nutrients into the water. Nutrients support plankton. Plankton support krill. Krill support penguins, seals, whales, fish, seabirds, and a whole cold water food web that depends on timing, temperature, movement, and abundance. The surface may look hostile, but the ocean is not empty. It is busy. It is feeding, moving, exchanging, and supporting life in ways that are easy to miss when all you can see is grey water and spray. Seabirds know this better than most of us. Albatrosses, petrels, and other southern birds are built for these winds. To a passenger gripping a mug with both hands, the weather may feel unreasonable. To an albatross, it is a road. These birds use the wind with remarkable skill, gliding for long distances with barely a wing beat, rising and dipping over the swells as if they understand the shape of the air itself. Watching them from a ship can be strangely calming. The vessel may roll, the horizon may tilt. Someone may be quietly regretting the second helping of lunch. But outside, a bird with long, narrow wings moves through the gale with complete confidence. That contrast is one of the reasons the Drake Passage holds the imagination. It is harsh for humans, but not meaningless. It is dangerous for ships, but not chaotic in the sense of being random. The passage follows rules. They are just very large rules. Wind, current, pressure, temperature, geography, and distance all combine to produce the conditions that make the crossing famous. The more closely we look, the less the Drake seems like a monster, and the more it becomes a place where the atmosphere and ocean show what they can do when given enough space. Still, knowing the science does not make the crossing entirely comfortable. It may help, but it will not stop the ship moving. Understanding wave formation does not make a rolling cabin feel less odd at 3 a.m. Knowing that the Antarctic circumpolar current is a major driver of global ocean circulation does not necessarily help when your toothbrush has escaped from the sink area and is now exploring the bathroom floor. This is the humble side of oceanography. The facts are magnificent. The lived experience may involve holding on to furniture. Perhaps that is why the Drake Passage works so well as a subject for a quiet night's journey. It gives us the large and the small at the same time. There is the scale of continents, oceans, currents, storms, and climate. Then there is the scale of a person standing at a ship window, watching water move past in long, grey ridges, wondering how something so wide can still feel like a crossing from one world into another. Antarctica waits beyond it, but the passage itself has a presence. It is not just the space before the destination, it is a place with its own character. Many people who cross to Antarctica remember the first sight of land after the Drake. After 2 days of open water, the sudden appearance of dark rock, white ice, and distant mountains can feel startling. The ship has carried them through movement and uncertainty, and then there it is, the edge of the Antarctic world. But before that moment comes the water, before the penguins, before the icebergs, before the photographs and the careful steps ashore, there is the crossing. There is the sound of the hull meeting the sea. There is the weather report. There is the quiet calculation of whether walking across the room is worth the effort. There is the strange feeling of being very small on a very large planet. That feeling is not a bad one. In fact, it may be useful. The Drake Passage reminds us that not every place is designed around human comfort. Some places are still governed by forces that are older, stronger, and much less interested in convenience. We can study them, forecast them, cross them, and sometimes even enjoy them. But we do not control them, and there is a kind of relief in admitting that. The ocean is not being rude, it is being the ocean. Tonight, we will move through the Drake Passage slowly, without needing waterproof boots or a strong stomach. We will look at why this stretch of water exists, why it behaves the way it does, why the winds there are so persistent, and why the current that runs through it matters far beyond Antarctica. We will spend time with the waves, the ships, the history, the wildlife, and the calmer days when the Drake turns almost gentle. We will not rush toward drama. The facts are dramatic enough. We can let them arrive at a reasonable pace, which is more than the weather often does down there. For now, picture the route. A ship leaves Ushuaia, or another southern port, and moves out through colder water. The last signs of South America fall away behind it. The mountains become lower, then faint, then gone. Ahead is open ocean. There are no trees, no streetlights, no roads, no easy landmarks. The sky feels large. The water has a heavy look. Somewhere far ahead, beyond the reach of sight, lies the Antarctic Peninsula. Between here and there is the Drake Passage, wide enough to feel endless, narrow enough to concentrate the movement of the Southern Ocean, and famous enough that even people who have never crossed it may know its name. The ship continues south. Inside, passengers settle into cabins, lecture rooms, lounges, and dining areas. Some are excited, some are cautious, some are already wearing seasickness patches and speaking with the careful optimism of people who have made a private agreement with their inner ear. Outside, the sea begins its work. Perhaps it is mild, perhaps it is not. The crossing may be a slow rock, a firm roll, or a full introduction to why chairs on ships are often heavier than they look. Either way, the passage has begun. And to understand why this water can be so unsettled, we should first look at the meeting place itself, where the geography of the far south gives wind and current a rare kind of freedom, and where two great pieces of the world, South America and Antarctica, leave just enough space between them for the ocean to show its strength. The first thing to understand about the Drake Passage is that it is not only a stretch of water between two places, it is a meeting point. To the north, the last rugged edge of South America leans into the cold air. To the south, Antarctica waits beyond the horizon, white, silent, and not especially concerned with making the journey easy. Between them is a gap of ocean wide enough to feel endless when you're crossing it, but narrow enough, in planetary terms, to gather some very large forces into one busy space. On a map, the Drake Passage looks almost simple. There is Cape Horn near the bottom of South America. There are the South Shetland Islands above the Antarctic Peninsula. There is blue water between them, a neat little gap, a convenient crossing, a place where a ship can move south and eventually arrive in a world of ice. But maps are very good at making difficult things look tidy. A line on paper does not show wind pressing against the surface for thousands of miles. It does not show water sliding over underwater ridges. It does not show cold layers, warmer layers, currents, countercurrents, pressure systems, or the slow decision your stomach makes when the floor begins moving in 3 directions at once. The Drake Passage sits where the Atlantic and Pacific Ocean systems come close together at the bottom of the world. Some people describe it as the place where the Atlantic and Pacific meet. Others speak of it as part of the Southern Ocean, that great belt of water surrounding Antarctica. Both ideas help, though neither fully captures the experience. This is not like two polite rivers meeting in a valley, one brown and one blue, gently blending while birds sit nearby and pretend to be impressed. This is a wider, rougher, more complicated meeting. Water from different ocean basins is moved, mixed, chilled, stirred, and carried by currents that do not pause for introductions. The reason this matters is geography. Antarctica is surrounded by ocean. That sounds obvious, of course, but it is one of the most important facts about the planet. In the far south, there is no continuous chain of land blocking water from travelling around the globe. The ocean has a path all the way around the Antarctic continent. Because of that, the water can circulate in a broad ring, driven by strong westerly winds and shaped by Earth's rotation. The Drake Passage is one of the narrowest places along that ring, and when a great moving system reaches a narrow point, the results can become energetic. You can think of it in a very ordinary way. If people are walking through a wide open field, they spread out. They move at different speeds. Some wander, some pause, some probably check their phones. But if all of those people have to pass through one gate, the movement becomes concentrated. There is less room. The flow tightens. A little bumping and shuffling may occur. The Drake Passage is not a garden gate, of course. It is hundreds of miles wide, but compared with the enormous sweep of the Southern Ocean, it is a constriction. And through it moves water connected to the Antarctic Circumpolar Current, the huge current that circles Antarctica and helps link the major ocean basins. That current is one of the main characters in this story, though it does not arrive with dramatic music. It simply moves steadily, relentlessly, west to east around Antarctica, carrying vast amounts of water. It is often described as the strongest ocean current on Earth, which is the sort of title that sounds as if it should come with a small trophy and perhaps a warning label. It is driven mainly by the winds that blow around the Southern Ocean, and because those winds do not meet many large land barriers, they can keep pushing. The current does not just affect the Drake Passage, it helps shape the Southern Ocean, the climate around Antarctica, the exchange of heat and carbon, and the movement of nutrients that support marine life. So when a ship crosses the Drake Passage, it is not merely crossing distance, it is crossing motion. The water underneath is not passive, it is not a blue carpet spread between South America and Antarctica. It is part of a moving global system. It carries signals from one ocean into another. It guides icebergs. It helps separate the cold Antarctic world from warmer waters farther north. It contributes to the strange isolation of Antarctica, not by building a wall, but by keeping a ring of moving water around it. This is one reason the passage can feel so alive. Even on a calm day, there is a sense that the water has a job to do. The surface may be smooth enough to reflect a pale sky, but beneath it, the ocean is still working. Layers of water are moving at different depths. Cold, dense water is interacting with lighter water above. Currents are crossing uneven sea floor. The ship may seem to be travelling through open emptiness, but the sea below is organised in ways that are hard to see from the deck. The seafloor matters more than most people imagine. We tend to think of rough water as something caused only by wind at the surface, but underwater geography also shapes the sea. The bottom of the Drake Passage is not a flat bowl. It contains ridges, rises, trenches, and rough features that influence how deep currents move. When a powerful current meets uneven sea floor, it can create turbulence, eddies, and changes in flow. The ocean does not simply slide along like a tray on a table. It is pushed, lifted, squeezed, and redirected by the hidden shape beneath it. This is where the Drake Passage begins to earn its difficult reputation in a more detailed way. It is not just that big waves happen there, though they do. It is that several difficult ingredients are found in the same place. Strong winds, long stretches of open water, powerful current, a narrow global ocean gateway, deep water, rough sea floor, rapid weather changes, cold air, cold spray, and occasionally passengers who were very confident in the gift shop before departure and are now lying very still in their cabins, having developed a close personal relationship with the ceiling. The meeting of ocean systems also creates a boundary in temperature and climate. North of the passage, around Tierra del Fuego and the southern tip of South America, conditions are cold, windy and wet, but still not truly Antarctic. South of it, closer to the Antarctic peninsula, the world changes. The air feels sharper, ice becomes more common. Snow, glaciers and sea ice begin to define the view. The Drake Passage is part of that transition. It is not a doorway with hinges and a handle, but it does separate one kind of world from another. For sailors, this transition was never just scientific. It was physical. It was practical. It was the difference between progress and trouble. A ship leaving the more sheltered waters near the southern end of South America could quickly find itself exposed to the full force of the Southern Ocean. There is a very specific kind of honesty in open water. Land gives shelter, islands break swell, bays allow anchorage, but in the Drake, once you are out, you are out. The ocean has room to move under you, and the weather has room to arrive. That is why the phrase "where two oceans meet" can sound almost too gentle. It suggests a meeting room, perhaps with tea. But the Drake Passage is less like a meeting and more like a busy kitchen during a dinner rush. Everything is moving. Heat is being exchanged. Directions are changing. Pressure is building. Someone has opened a door at the wrong time. And in the middle of it all, a ship is trying to pass through with as much dignity as possible. The Atlantic side and Pacific side of the Southern Ocean world do not behave as if they are neatly separated by invisible lines. Ocean water does not care very much about names printed in atlases. It moves according to density, wind, temperature, salinity, rotation, and geography. It follows physics, not human labelling. We give the waters names because names help us understand them, discuss them, and place them in memory. But the Drake Passage is a reminder that the planet is not built in tidy sections. It is connected. Water that has travelled from one basin can influence another. A current shaped in the far south can matter far beyond the place where a traveller first feels the ship begin to roll. There is something almost humbling about that. A person crossing the Drake may be thinking about very immediate things. Where is my cabin? Did I secure my camera? Why did I eat soup? How far is Antarctica? Meanwhile, the ocean is handling global business. It is helping move heat around the planet. It is transporting carbon into deeper waters. It is carrying nutrients toward places where plankton can bloom. It is guiding icebergs away from Antarctica and into warmer zones where they slowly break down. It is taking part in systems too large to fit comfortably inside human attention for very long. Still, the human experience matters because it is how most of us first understand a place. A scientific diagram can show the Antarctic circumpolar current with arrows. A satellite image can show cloud systems curling over the Southern Ocean. A chart can show temperature fronts and bathymetry. But a person on a ship understands the Drake in another way. They understand it through balance, through sound, through the small pause before walking down a corridor, through the way water hits the hull at night, through the sight of a horizon that rises, falls, disappears and returns as if it is having second thoughts. The meeting of waters also affects colour and mood. The Drake often appears grey, steel blue, green-black or white-streaked, depending on weather and light. It is not usually the cheerful turquoise of holiday postcards, unless the postcard is trying to sell you character development. The sky can hang low, clouds can move fast, visibility can shift quickly. 1 hour may bring a calm surface and distant birds. The next may bring spray, darker water, and a horizon softened by weather. This changeability is part of the passage's personality, though perhaps personality is too generous a word for a place that has caused so many people to sit quietly with crackers. To be fair, the Drake is not always violent. This is important. Its reputation is strong, but it does not spend every hour throwing waves at ships like an angry waiter. There are calmer crossings. There are days when the water opens smoothly ahead, and passengers begin to wonder whether the stories were exaggerated. The sea can flatten into long, gentle swells. The sky can clear. Birds can follow the vessel in easy arcs. People come out onto deck, take photographs, and speak warmly of how lucky they are. Some may even use phrases like, "not bad at all," which is always a dangerous thing to say within earshot of the Southern Ocean. The possibility of calm does not weaken the Drake's reputation. It makes it more interesting. A predictable danger is one thing. An unpredictable one requires more respect. The passage can be mild, rough, or somewhere in between. Forecasts help, modern ships help, experienced captains help, but no one commands the sea into good behaviour. The crossing always contains a degree of uncertainty. That uncertainty is part of why it remains famous even in an age of advanced navigation and weather models. When two ocean systems meet and mix, they also create conditions for life. This may seem surprising when looking at the surface. Rough cold water does not immediately suggest abundance. It suggests waterproof gloves and a strong desire for indoor heating. but the Southern Ocean is rich in biological activity because of the way currents and mixing bring nutrients upward. In the right conditions, nutrients support phytoplankton, the tiny drifting organisms that form the base of much of the marine food web. From there, energy passes to krill, fish, squid, seabirds, seals, penguins, and whales. The Drake Passage, then, is not only a dangerous route, it is part of a living ocean. The same forces that make it hard to cross help make it productive. Wind and current stir the water. Fronts mark changes in temperature and nutrients. Eddies can carry life and chemistry across boundaries. The ocean is not still enough to be comfortable, but that movement helps feed the system. A passenger may see only grey waves, but below and around those waves is a web of feeding, drifting, hunting, and migrating. This is why seabirds are such a constant presence in many accounts of the crossing. Albatrosses and petrels seem to belong there in a way humans do not. They use the air over the waves with extraordinary efficiency, gliding across winds that make people tighten their hoods and question their choices. Their bodies are suited to this unsettled world. Long wings, careful angles, patient movement. They do not fight the wind in the way a person might imagine. They work with it. While a ship rises and falls heavily, a bird may pass beside it with almost casual skill, as if the whole roaring system were simply a road it knows well. That is another lesson of the Drake Passage. Dangerous for whom? Rough for what? To a small boat it may be deadly. To a modern expedition vessel, it is a serious crossing to be planned and respected. To an albatross it is useful air. To krill, it is part of a moving habitat. To an iceberg, it may be the start of a long journey north and east. To Antarctica, it is part of the surrounding ocean system that helps keep the continent separate from warmer regions. The passage is not one thing to every living being. It depends on your body, your scale, your purpose, and whether you are foolish enough to bring a loose cup of tea into a rolling lounge. The meeting of oceans also changes how we think about borders. On land, borders can feel sharp. A fence, a sign, a road crossing, a customs booth where everyone pretends to know exactly where their passport is. At sea, boundaries are more fluid. The line between the Pacific and Atlantic can be drawn on charts, but the water itself is layered and moving. The Southern Ocean is recognized as a distinct ocean by many scientific and educational systems because its circulation around Antarctica is so different from the ocean basins to the north. Yet even then, the boundaries are not walls. They are zones of change. The Drake Passage sits in one of those zones. It is a place of exchange, wind exchange, heat exchange, water exchange, biological exchange. It is a working border, not a painted one. The conditions there are produced by movement across the boundary, not by stillness on either side. That is why it can be hard to describe in one sentence. It is a strait. It is a crossing. It is a gateway. It is a current pathway. It is a climate boundary. It is a wildlife corridor. It is also, depending on the forecast, a very convincing argument for lying down. For ships heading toward Antarctica, this meeting place becomes a test before arrival. The Drake is not merely something to endure. It prepares the traveller, whether they like it or not, for the remoteness of the continent beyond. The lack of land, the strength of the weather, the scale of the water, all of it reminds passengers that Antarctica is not a theme park with ice. It is reached by crossing a serious ocean. That seriousness gives the arrival more weight. When the first islands appear after the passage, they do not feel casual. They feel earned. Yet there is no need to romanticize the discomfort too much. Seasickness is not a spiritual lesson. It is mainly your inner ear and your eyes having a disagreement, while your stomach files a complaint. But even that small human inconvenience connects back to the large emotion of the sea. The ship rolls because energy has moved through air into water. The water rises because wind and current and distance have shaped it. Your body reacts because it evolved on land, where flaws usually keep their promises. In the Drake Passage, even the simplest human assumptions become negotiable. This is why the place can be both scientifically fascinating and personally memorable. It is not enough to say, the Atlantic and Pacific meet here, because what happens there is not a handshake. It is circulation. It is mixing. It is pressure and movement. It is cold water, wind stress, fronts, eddies, and deep flow. It is also breakfast plates sliding slightly on tables and passengers learning to walk with knees bent. The large and small versions of the Drake are always happening together. As the ship moves farther from South America, the meeting of oceans becomes less a fact on a map and more a condition surrounding everything. The air cools, the water changes, the birds may follow, the horizon stays open. There is a feeling of entering a zone where land has lost its authority. The names of oceans matter less than the behaviour of water. The vessel is now in the hands of the Southern Ocean System, and that system has been moving long before anyone gave it a name. This is where the Drake Passage begins to make sense, not as a random patch of bad weather, but as a natural result of planetary design. Put a cold continent at the bottom of the world, surround it with open ocean, let strong winds circle it, allow a huge current to move without a continent blocking the way, then narrow part of that path between South America and Antarctica, add rough seafloor, shifting pressure systems, and long stretches of open water where waves can grow. The result is not a mystery in the sense of being unknowable. It is a mystery in the older, quieter sense, something understandable enough to study, but still powerful enough to respect. And so the Drake Passage misbehaves, because from a human point of view it refuses to be simple. It is too connected, too exposed, too energetic, too full of moving parts. It does not offer the tidy comfort of a lake, even on the days when people call it one. It is a meeting place between named oceans, but also between weather and water, surface and depth, science and experience, fear and fascination. It can be crossed, measured, forecast, photographed, and described. But it cannot be reduced to a single mood. The ship continues on, with South America now behind and Antarctica still ahead. Beneath the hull, the water is moving through one of the most important passages on Earth. Above it, the wind has room to gather. Somewhere beyond sight, pressure systems are forming and shifting. The crossing may stay gentle, or it may begin to remind everyone why this route has such a famous name. Either way, the next reason for its reputation is already present in the air itself, because around these latitudes the winds do not behave like occasional visitors. They are regular residents, and they have been circling the planet with very little to stop them. They are regular residents, and they have been circling the planet with very little to stop them. Down in the southern latitudes, wind is not just weather that arrives for a while, and then wanders off. It is part of the structure of the place. It belongs there in the same way the cold belongs to Antarctica, and the long swell belongs to the open sea. Around the Drake Passage, the wind has room, distance, and a clear path. Those three things are enough to turn ordinary moving air into something that can shape ships, waves, currents, and the nerves of anyone trying to sleep in a narrow cabin, while the coat hangers perform a small metal orchestra in the wardrobe. The names alone tell you something about how sailors felt. The Roaring Forties, the Furious 50s, the Screaming 60s. These are not official names invented by a committee in a quiet office, with good biscuits. They came from sailors who crossed those latitudes and had opinions. Strong opinions. In the southern hemisphere, the belt between about 40 and 50 degrees south became known as the Roaring Forties because of the strong westerly winds that blow there. Farther south, between 50 and 60 degrees, the winds grow harsher and earn the name Furious 50s. Then beyond that, closer to 60 degrees south and below, sailors spoke of the Screaming 60s, where the Southern Ocean can feel less like a body of water and more like a large cold argument. The Drake Passage lies in the path of these wind belts. That is one of the major reasons it has such a reputation. It is not simply placed in a difficult part of the map. It is placed in a part of the atmosphere where the winds are built to travel. They move mainly from west to east, circling around the southern hemisphere, pushed by temperature differences, pressure systems, and the rotation of the Earth. In many parts of the world, continents interrupt winds. Mountains lift them, coastlines disturb them, forests slow them, cities roughen them, and land masses break up their flow. But in the far south, there is much less land in the way. The wind can run around the planet with fewer obstacles. That lack of land is a simple fact with serious consequences. A wind that is constantly interrupted loses some of its strength and shape. A wind that can travel over open ocean for thousands of miles can build and maintain energy. It keeps pressing on the water. It keeps raising waves. It keeps pushing the surface eastward. It becomes not just a weather event, but a regular force. It is a little like someone blowing across a cup of tea. Do it once and the surface ripples. Keep doing it steadily, for a very long time, across an ocean with hardly anything in the way, and you begin to understand why ships in the Drake Passage do not always behave like objects in a calm domestic setting. Wind begins with pressure differences. Air moves from areas of higher pressure toward areas of lower pressure, and because Earth is rotating, that movement is turned and shaped rather than travelling in a straight line. In the southern hemisphere, this turning helps create strong west to east winds in the mid and high latitudes. The details can become complicated, and there is no need to wrestle every equation into the room tonight. The important thing is that the atmosphere around the Southern Ocean is arranged in a way that allows these powerful westerly winds to persist. They are not rare visitors. They are part of the normal machinery of the region. This is why the Drake Passage can change so quickly. The passage sits beneath a busy track of weather systems. Low-pressure systems move through, fronts pass over the water, winds strengthen, shift, and sometimes arrive with very little interest in passenger comfort. One moment the sea may seem manageable, with a long roll under the ship and clouds moving in layers. Later, the wind can rise, the tops of the waves can begin to blow white, and the entire surface may look as if it has been brushed the wrong way by an enormous hand. The ship keeps going, of course, because ships are built for this. Passengers, on the other hand, are often built more for sofas. The wind does not only make the air feel harsh, it transfers energy into the water. That is how waves grow. At first, wind creates small ripples. Then, as it continues blowing, those ripples become waves. If the wind is strong, steady, and has a long distance of open water to work across, the waves can become much larger. That distance is called fetch, and in the Southern Ocean the fetch can be extraordinary. With few land barriers, waves can travel and organise over vast areas. By the time swell reaches the Drake Passage, it may have been shaped by storms far away, by winds that passengers never saw, and weather systems that began their work long before the ship left port. This is one of the reasons the Drake can feel unfair. The weather directly above you may not seem terrible, but the sea can still be moving with energy from somewhere else. A ship may be under a pale sky, with only moderate wind, and still rise and fall on a deep swell that has travelled from a distant storm. The ocean remembers wind longer than the air does. The air changes mood and moves on. The sea keeps the message for a while. That message may arrive as a slow lift, a sideways roll, or a heavy movement under the hull that causes everyone in the dining room to pause at exactly the same time. There is a difference between wind waves and swell, though on a rough day most passengers are not in the mood to appreciate the distinction. Wind waves are formed by local winds. They can be steep, choppy, and confused, especially when the wind is actively blowing over the surface. Swell is made of waves that have travelled away from the place where they were created. Swell can be long and powerful, moving across open ocean with a steady rhythm. In the Drake Passage, these can combine. Local wind may roughen the surface while longer swell rolls underneath. This gives the sea a layered movement, one that can make a ship rise, roll, and twist, in ways that seem personally targeted, though the ocean is almost certainly not keeping a list. The famous wind belts were both feared and used by sailors. In the age of sail, strong westerly winds could be dangerous, but they could also help ships travel quickly eastward. Sailing ships crossing the southern oceans sometimes used these winds to make faster passages. That was the practical bargain. The same winds that could tear sails, exhaust crews, and push vessels into dangerous seas could also carry them across enormous distances. Sailors did not simply avoid these latitudes because they were rough. In many cases, they entered them because the wind was useful. It was power. Not comfortable power, certainly not polite power, but power all the same. For the Drake Passage, this mattered deeply. Ships trying to move around the southern tip of South America had to deal not only with the sea route, but with the winds that gathered around it. Before modern engines, a sailing vessel depended on wind, yet too much wind from the wrong direction could be disastrous. Rounding Cape Horn became one of the great tests of seamanship because the region combined strong winds, large seas, cold conditions, and difficult navigation. A crew could be battered for days or weeks, trying to make progress against weather that seemed determined to send them somewhere else. It was not romantic in the moment. It was wet work, dangerous work, and probably involved more shouting than any painting of a tall ship would suggest. Modern vessels are far safer and more capable, but the wind still matters. Expedition ships crossing to Antarctica are designed and operated with these conditions in mind. Captains study forecasts carefully. Routes and speeds may be adjusted. Loose objects are secured. Passengers are warned to keep one hand free when walking, which sounds simple until you are carrying a cup, a camera, a jacket, and the quiet dignity you hope to preserve. Even with modern technology, the wind remains a central part of the crossing. It decides the sea state. It shapes the timing. It affects comfort, visibility, and the mood of the ship. Inside a vessel, wind is often first understood as sound. It presses against the windows. It moves around corners. It hums through railings and rattles small fittings. At night, when there is no land outside and the cabin light has been switched off, the sound can make the ship feel very small. Not unsafe necessarily, but small. The sort of small that reminds you the planet is much larger than your plans for breakfast. The hull moves through dark water. The wind moves over it. Somewhere outside, spray lifts off the wave tops and disappears into the black air. Inside, someone tries to sleep while a drawer gently opens, and closes again, as if considering a career in percussion. Above the Drake Passage, a weather system moves in a broad west to east flow. Low-pressure systems can deepen over the Southern Ocean and bring stronger winds. These systems are part of why the region is known for storminess. The winds do not blow at exactly the same strength all the time, of course. There are lulls, there are calmer windows, there are days when the passage seems almost reasonable, and passengers begin to believe they have been granted a special arrangement. But the background pattern remains. This is a windy part of the world, and calm is not the default expectation in the way it might be on a sheltered lake on a still summer morning. The wind also affects temperature. Strong wind makes cold feel colder because it strips away the thin layer of warm air near the body. On deck, even when the thermometer is not showing a shocking number, the wind can make the air feel sharp. Gloves become useful. Hoods become important. Words are spoken more carefully because the wind has a habit of taking them away. A person may step outside to admire the sea and return 10 minutes later with a red nose, watery eyes, and a renewed respect for indoor carpeting. For wildlife, though, the same wind can be an advantage. Albatrosses are the great example. These birds are almost impossible to discuss in the Southern Ocean without sounding slightly impressed, because they deserve it. They use a technique called dynamic soaring, taking advantage of differences in wind speed above the waves. By climbing into stronger wind and descending into slower air near the surface, they can travel huge distances with very little flapping. To us, the wind feels like resistance. To them, it is energy. They turn the restless air into movement. A rough day for a ship can be a workable day for an albatross. Watching birds in the Drake Passage can change how the wind feels. A human sees harshness. a bird shows skill. It banks, glides, rises, dips, and follows the shape of air that we cannot see. The sea is moving below. The ship is working through the swell. The wind is loud enough to make conversation awkward. And there, just beyond the rail, a bird seems to draw a clean line through it all. Not because the weather is gentle, but because the bird belongs to it. That is an important difference. Wind also helps drive the surface waters of the Southern Ocean and contributes to the Antarctic circumpolar current. The relationship between wind and current is not as simple as wind pushing a toy boat across a pond, but the basic idea is that persistent westerly winds apply stress to the ocean surface. That stress helps set water in motion and supports the eastward flow around Antarctica. The current is also shaped by density differences and seafloor features, but the wind is a major driver. So the wind belt above the Drake Passage is not only making waves, it is helping power one of the largest moving systems in the ocean. This means the atmosphere and ocean are tightly linked here. The wind shapes the sea. The sea influences the air above it through heat, moisture, and surface conditions. Storms move through, waves build, currents respond, and the whole system continues. A traveller may think of wind as something outside the ship, and water as something below it, but in the Drake, they are parts of the same conversation. A loud conversation, admittedly. One that may occasionally throw spray at the windows, but a conversation all the same. The Southern Hemisphere wind belts also help explain why the Drake Passage has such a different feel from many northern sea routes. In the north, continents break up the ocean. There are large land masses at high latitudes, and those land masses interfere with the clean circular flow of wind and water. In the south, the ocean around Antarctica is much more continuous. This gives the weather a more open track. The winds can circle, storms can travel, and waves can build over distances that are difficult to grasp from a normal map. The Drake Passage is not isolated from that wider system. It is one of the main places where a ship directly encounters it. There is a strange fairness in the wind. It does not care whether a passenger has waited 10 years to visit Antarctica. It does not care whether the captain would prefer a comfortable crossing. It does not care whether the onboard lecture about penguin behaviour is scheduled for 3 o'clock and would be easier to enjoy if chairs were not gently sliding. Wind follows pressure and physics. It moves because the atmosphere requires movement. It blows over the Drake Passage because the planet has arranged conditions that way. Human preference, while understandable, is not one of the controlling variables, and yet humans adapt. That is one of the quieter stories of the Drake Passage. People learn the ship's rhythm. They walk more slowly. They place a hand against the wall without thinking. They secure bottles, cameras, notebooks, and anything else that might develop ambitions. Crew members move with practiced ease, reading the motion in their legs before their minds need to comment. Passengers who were cautious on the first day may grow more confident by the second. The wind may still be outside, the sea may still be moving, but the body begins to negotiate. This negotiation has always been part of seafaring. Sailors learned the patterns of wind long before satellites or modern meteorology. They named the belts because naming helps people survive and remember. The roaring 40s, furious 50s, and screaming 60s were not just colourful phrases. They were warnings and tools. They told sailors what kind of world they were entering. They described the feel of the latitudes in language that could be carried from one voyage to another. A name like the Furious 50s does not require much explanation. It arrives already wearing a raincoat. The Drake Passage sits close enough to these names to inherit their atmosphere. Not every crossing will involve the worst of them, but the reputation is there because the ingredients are there. Strong westerlies, open ocean, long fetch, fast-changing weather, a narrow gap near the bottom of the world. The wind belt does not sleep because the global circulation does not sleep. Air keeps moving, pressure keeps changing, and the planet keeps turning. Somewhere, even while the sea seems calm, Another weather system is forming. Another swell is travelling. Another ship is preparing to leave port with passengers who have been told, very kindly, that it might be wise to take medication before they feel they need it. The wind also creates mood. This is not a scientific measurement, but anyone who has been in a windy place understands it. A calm landscape can feel open and still. A windy one feels active. It demands attention. It pulls at clothing, changes posture, and fills silence. On the Drake Passage, the wind helps create the sense that the crossing is not empty time between departure and arrival. It is an event. It turns the outside world into something you listen to as much as see. It makes the windows tremble slightly. It sends spray sideways. It lifts the tops from waves and blows them into white streaks. It gives the sea a surface texture that constantly changes. At times, the wind can flatten parts of the wave face, tearing spindrift from the crests and smearing it across the surface. At other times, it builds short, steep chop on top of longer swell, making the ocean look confused and busy. The ship's bow may rise, then drop, sending water outward. The wake disappears quickly behind it. Birds appear, vanish, and reappear in the weather. The horizon is sometimes sharp, sometimes blurred, sometimes hidden behind rain or spray. This is the Drake Passage under the influence of the wind belt, and it is not hard to see why sailors remembered it. Still, there is comfort in understanding. A frightening thing becomes less frightening when it has causes. The wind is not random anger, it is moving air shaped by pressure, temperature, latitude, and rotation. The waves are not personal attacks, they are energy travelling through water. The roughness of the Drake is not a supernatural mood. It is the natural result of a rare arrangement of ocean and atmosphere. Knowing that does not make a rough crossing smooth, but it can make it feel less mysterious in the wrong way. It becomes a place to respect, not a monster to imagine. And respect is the right word. Fear alone can flatten a place into a threat. Respect allows more room. It allows for danger, beauty, science, inconvenience, wildlife, history, and the small comedy of humans trying to drink tea on a moving platform. The wind belt that crosses the Drake Passage deserves that kind of respect. It has shaped routes, delayed ships, helped sailors, exhausted crews, fed waves, powered currents, and carried birds across distances that make human travel seem fussy and overpacked. As the ship continues south, the wind may rise or ease. The crew watches instruments. The passengers watch the horizon, or avoid watching it depending on personal strategy. Outside, the air keeps moving over the water in long invisible bands. It has travelled far to get here. It may continue far beyond the ship. It will press on the surface, build waves, and help keep the great southern current turning around Antarctica. And that current, moving beneath the influence of the wind, is the next great force waiting beneath the story of the Drake Passage. A river in the ocean so wide and powerful that it helps separate Antarctica from the rest of the world. And that current, moving beneath the influence of the wind, is the next great force waiting beneath the story of the Drake Passage. A river in the ocean so wide and powerful that it helps separate Antarctica from the rest of the world. Of course, when most of us hear the word river, we picture something with banks. A river has edges. It passes under bridges. It has a source and a mouth. It may move through a forest, a city, a valley, or past a place where someone is trying very seriously to feed ducks, despite several signs asking them not to. But the Antarctic circumpolar current is not that kind of river. It has no neat shoreline. It does not run between grassy banks. It does not make a cheerful sound over stones. It is an ocean current, enormous, deep, wide, and constantly moving around Antarctica. It circles the continent from west to east, pushed along by the strong westerly winds we have just met. It connects the Atlantic, Pacific, and Indian Oceans. It carries water around the bottom of the planet in a continuous loop, and because no large landmass blocks its path, it can keep going again and again around the coldest continent on Earth, This is one of the reasons Antarctica is so different from everywhere else. It is not just far away on the map. It is surrounded by moving water that acts almost like a boundary, not a wall. The ocean is never that simple, but a boundary all the same. Warm water from farther north cannot just wander down to Antarctica as easily as it might in another arrangement of continents and seas. The current helps keep the Antarctic region isolated. It helps maintain the difference between the cold polar waters near the continent and the somewhat warmer waters farther north. That separation has mattered for millions of years. It has helped shape the ice, the climate, the animals, and the entire character of the southern end of the planet. So when we talk about the Drake Passage, we're not only talking about a rough crossing for ships, we're talking about one of the places where this huge moving system squeezes through a gap and shows its strength. Imagine standing on the deck of a ship in the Drake Passage. The wind is cold, the water is dark, the horizon is wide and restless. It may look like you're simply crossing a rough patch of sea, but beneath the ship is part of a current that belongs to the whole planet. Water is moving through that space in quantities too large to picture easily. If you tried to compare it to rivers on land, the numbers would quickly become ridiculous. It is far larger than any river you can stand beside. There is no little wooden sign saying, "Welcome to the current." There is only the sea moving under you, mile after mile, with a power that does not need to announce itself. This is where the Drake Passage becomes more than a notorious strip of water. It becomes a gateway in global ocean circulation. The Antarctic circumpolar current travels around Antarctica, but the Drake Passage is the narrowest major opening along that route. South America reaches down toward Antarctica. Antarctica reaches up with the Antarctic Peninsula. Between them, the current has to pass through. It is still a huge space, wide enough that a person on a ship sees only water in all directions, but for an ocean system that circles the globe, it is a narrowing, and narrowing matters. When moving water passes through a restricted space, its behaviour changes. It can speed up, it can become more energetic, it can interact more strongly with the seafloor. It can form eddies, fronts, and zones of mixing. In the Drake Passage, the current is not gliding through a smooth hallway. The ocean floor beneath it is uneven, with ridges and deep sections that shape the way the water moves. The current meets underwater obstacles, and those obstacles disturb its flow. The result is not chaos in the simple sense. It is organised movement made complicated by real geography. This is one reason scientists care so much about the Drake Passage. It is a useful place to study the current because so much water passes through it. Measurements in this region help researchers understand how the current changes, how strong it is, how heat and carbon are being moved, and how the Southern Ocean is behaving over time. For people on a ship, the Drake may feel like a challenge to cross. For oceanographers, it is also a place where the planet reveals some of its operating instructions. The Antarctic circumpolar current is sometimes described as the largest ocean current in the world. That is not just a dramatic title. It reflects the amount of water it transports and the way it links ocean basins. Water from the Atlantic, Pacific and Indian Oceans can all be connected through this current. This makes it a major part of the global ocean system, the slow, complex circulation that moves heat, salt, nutrients and gases around the planet. It helps the oceans behave less like separate containers and more like connected rooms in one very large, very damp house. A house, it must be said, with poor heating in the basement. The Southern Ocean, through this current, plays a major role in climate. Oceans absorb heat, they absorb carbon dioxide, they store and move energy. Around Antarctica, cold surface waters, deep waters, winds and currents interact in ways that affect the wider climate system. When water sinks, rises, mixes or moves between regions, it carries properties with it: temperature, salt, dissolved gases, nutrients. These are not decorative details. They influence ecosystems, weather patterns, and the long-term behaviour of climate. For a sleepy evening story, that might sound like a lot of responsibility for one current. But oceans do not mind responsibility. They have been doing this long before humans arrived with instruments, maps, and waterproof notebooks. The current also helps bring nutrients toward the surface in certain regions. This matters because nutrients feed phytoplankton, the tiny plant-like organisms drifting in the upper ocean. Phytoplankton may be small, but they are not minor. They are the base of many marine food webs. Where phytoplankton bloom, krill can feed. Where krill gather, penguins, seals, whales, fish, and seabirds may follow. So the same current system that makes the Drake Passage physically difficult also helps support the life of the Southern Ocean. This is one of the quiet contradictions of the Drake. The surface can appear harsh, grey and almost empty. But that harshness is part of a productive system. The movement that makes a ship roll can also help move nutrients. The wind that makes passengers zip their coats to the chin can help drive circulation. The cold water that seems unfriendly to human skin is home to an entire chain of life adapted to the far south. The Drake Passage may not look inviting, but it is not dead water. It is working water. There is also a temperature boundary connected with the current, often discussed in terms of fronts. Ocean fronts are not walls, but zones where water properties change. Temperature, salinity, and density shift across them. In the Southern Ocean, these fronts help organise the current and separate different water masses. A ship crossing southward may pass through these zones without anything obvious happening on deck. There may be no dramatic line in the water, no signpost, no little bell. But instruments can detect the changes. The ocean is layered with boundaries that human eyes often miss. In that way, the Drake Passage asks us to think differently about place. On land, we use visible markers: a mountain range, a road, a fence, a riverbank. At sea, some of the most important boundaries are invisible at the surface. They are measured in temperature, salt, depth, movement, and density. A person may look out and see the same grey water for hours, while beneath and around the ship it is crossing through different zones of the ocean. The water knows its differences, even when we do not see them. The Antarctic circumpolar current also matters because it helps control how Antarctica interacts with the rest of the planet. The current does not completely seal Antarctica away, but it does help limit the exchange of warmer water from lower latitudes. This has helped keep the continent cold and icy. Antarctica's massive ice sheets did not form because of the current alone, but the current has been part of the larger story. When the circulation around Antarctica developed in Earth's past, it contributed to the continent's isolation and cooling. It helped create the cold world we now associate with Antarctica. That means the Drake Passage is tied to deep time as well as modern travel. It is easy to think of it only in terms of expedition cruises, weather forecasts, and dramatic wave videos. But the passage is also part of a geological and climate history that reaches far beyond human memory. The opening between South America and Antarctica allowed a full circumpolar flow to develop. Once water could move around Antarctica without being blocked, the Southern Ocean changed. The continent changed. The climate system changed. The Drake Passage became not just a route between places, but a key opening in the layout of Earth's oceans. This gives the current a kind of importance that is hard to feel at first. You do not stand beside it like a monument. You do not see a single clear stream. You cannot point to one wave and say, "There it is, the current." It is too large for that. It is experienced as a region, a movement, a system. The ship moves through it, over it, and with it. Instruments measure it. Birds use the air above it. Whales feed in waters influenced by it. Icebergs drift with the wider circulation around Antarctica. The current is not a single visible object. It is a moving condition. And moving conditions are often what matter most on Earth. Weather is a moving condition. Climate is a pattern of moving conditions. Ocean circulation is a network of moving conditions. We live inside these systems, whether we think about them or not. The Drake Passage makes that easier to notice because the movement becomes physical. The ship rises, the wind pushes, the swell passes under the hull. Passengers adjust their balance. Suddenly the idea of a moving planet is no longer something from a classroom diagram. It is under your feet. The current also helps explain why the sea state in the Drake can be so complicated. Wind may build waves from above. Swell may arrive from distant storms. Current may interact with the seafloor and with waves. When strong currents and strong winds combine, the surface can become confused and energetic. This does not mean every crossing is severe, but it does mean the region has many ways to become uncomfortable. The Drake does not rely on one trick, it has a whole drawer of them. A strong current can also change how waves behave. When waves meet current, especially if the current opposes the direction of a wave travel, waves can become steeper. In the Drake Passage, the exact interactions vary with conditions, but the broader point remains. Moving water below and moving air above make a lively partnership. Not always a pleasant one for passengers, but a lively one. If the sea were a kitchen, this would be the moment when several people are stirring different pots at different speeds, and no one has cleared the counter. The current is not uniform from top to bottom. Oceans have structure. Surface water differs from deep water. Temperature and salinity affect density. Density affects how water sinks, rises, and moves. The Antarctic circumpolar current extends through a large part of the water column, but different layers can behave differently. Deep water from other regions can enter the Southern Ocean. Cold Antarctic waters can form and spread. Mixing in the Southern Ocean connects surface and deep ocean processes in important ways. This vertical connection is one of the reasons the Southern Ocean is so important for carbon and heat. The ocean can take up carbon dioxide from the atmosphere. It can store heat below the surface. But how much it takes up, where that heat and carbon go, and how long they remain stored depends on circulation and mixing. The winds over the Southern Ocean, the current around Antarctica, and the upwelling of deep water all influence this exchange. In a practical sense, the Drake Passage is not only a difficult place for ships, it is part of a system involved in the planet's breathing and heat storage. That may sound like a large claim, but the ocean really does work on that scale. It does not make speeches about it. It simply absorbs, releases, carries, stores, and moves. The atmosphere and ocean trade heat and gases at the surface. The current transports water around Antarctica. Deep and surface layers interact. The result affects climate far beyond the view from any one ship. A passenger may be wondering whether lunch will stay where lunch is meant to stay. At the same time, the ocean beneath them is participating in processes that matter to the entire Earth. This contrast is almost funny if you let it be. The same crossing can be both a major part of global circulation and a personal test involving crackers, ginger tea, and careful breathing. Human beings are good at shrinking large systems down to how they feel in the body. This is not wrong. It is just our scale. We meet the current through motion. We meet the climate system through weather. We meet planetary forces through small daily inconveniences. The Drake Passage is honest about that. It does not separate science from experience. It puts them in the same rolling corridor. For the crew of a ship, the current is part of route planning and navigation. Modern vessels have powerful engines, accurate charts, satellite data, radar, weather forecasts, and experienced officers. They are not at the mercy of the current in the way old sailing ships might have been, but they still work with conditions rather than ignoring them. A captain crossing the Drake studies wind, sea state, swell direction, pressure systems, ice reports, and timing. The current is one piece of a larger operating picture. The goal is not to defeat the Southern Ocean. The goal is to cross it wisely. For earlier sailors, currents were both help and hazard. A current could carry a ship faster or push it away from where it needed to go. It could complicate dead reckoning, affect, steering, and make dangerous coastlines more dangerous. In the waters around Cape Horn and the Drake Passage, where storms, poor visibility and cold were already serious problems, current added another layer. Long before anyone fully understood the Antarctic circumpolar current, sailors knew that the southern waters had force. They felt it in drift, delay, damage, and the hard work of keeping a vessel safe. Today, we can describe the current with satellites, floats, moorings, ship measurements, and computer models. Scientists can estimate transport, track changes, and study how the current responds to winds and warming. Yet the current remains difficult to measure completely because it is vast, variable, deep, and remote. The Southern Ocean is not a convenient laboratory. It is cold, rough, and far from many major research ports. Instruments must survive difficult conditions. Ships must cross hard seas. Data has to be gathered from one of the least comfortable workspaces on Earth, which is perhaps why oceanographers deserve more warm beverages than they usually get. The Drake Passage has become a key place for long-term observation because the current is squeezed through a relatively narrow space there. By measuring the flow through the passage, scientists can learn about changes in the larger current system. This is another example of the Drake's unusual importance. It is a rough crossing for travellers, a historic challenge for sailors, a wildlife corridor, and a scientific window into global circulation. Few places manage to be that many things while also being famous for making people lie down. The current strength also influences ice. Icebergs that break away from Antarctica can be carried by currents into the Southern Ocean. Some drift northward and melt as they enter warmer waters. Sea ice expands and retreats seasonally, shaped by winds, temperature, and ocean conditions. The Antarctic circumpolar current is part of the broader environment that affects how ice and water interact. Around Antarctica, the line between ocean and ice is never just scenery. It is an active boundary, changing through seasons and responding to climate. For animals, the current and its fronts can help define feeding areas. Whales may travel long distances to feed in productive Antarctic waters. Penguins and seals depend on food webs linked to krill and fish. Seabirds range over huge areas, following winds and food. The current helps connect these habitats and influences where nutrients and prey are found. A rough sea surface may hide this activity, but it is there. Beneath the grey water are migrations, feeding patterns, and survival strategies built around cold, movement, and timing. Krill deserve a special mention because so much of the Antarctic food web depends on them. These small crustaceans feed many larger animals, including whales, seals, penguins, squid, fish, and seabirds. They are not impressive in the way a breaching whale is impressive. No one sees krill and whispers, majestic, unless they are a marine biologist having a particularly good day. But krill are essential. Their abundance depends on sea ice, phytoplankton, temperature, and ocean circulation. The current helps shape the environment in which this food web operates. So the Great Ocean River is not just moving water, it is moving the conditions for life. It is also moving cold, not in a simple block, but through the circulation of water masses. The Southern Ocean forms and exchanges waters that spread into other ocean basins. Cold, dense water can sink and move through the deep ocean. Other waters rise toward the surface. These processes are part of the global overturning circulation, the slow exchange between surface and deep ocean. The Antarctic circumpolar current helps connect these processes around the southern end of the planet. It is like a central roundabout in the ocean system, though a very large one, and one where no one would enjoy driving a small scooter. The phrase, Great Ocean River, is helpful, but it has limits. A river usually flows downhill because of gravity. The Antarctic circumpolar current is driven by winds, pressure gradients, density differences, Earth's rotation, and the shape of the seafloor. A river has banks that hold it in place. This current is guided by fronts, bathymetry, and the absence of blocking land. A river can often be crossed by a bridge. This current is crossed by ships, satellites, drifting instruments, and the occasional anxious traveller with a paper bag folded very neatly nearby. Still, the image helps us remember that the ocean is not still. It moves in organised ways. It has routes, boundaries, exchanges, and long-distance effects. The Antarctic circumpolar current is one of the clearest examples of that. It is the only current that flows all the way around the globe without being stopped by land. That alone makes it unusual. Add its role in climate, ecology, and Antarctic isolation, and it becomes one of the most important currents on Earth. And the Drake Passage is where many people meet it. Not by reading a chart, not by studying a climate model, not by watching an animation of arrows moving around Antarctica. They meet it in the body, they feel the ship move, they hear the hull, they watch waves pass, they notice the cold wind, they see seabirds using the air above the current. They may not be able to point to the exact line where one water mass meets another, but they know they're in a place where the ocean is active. The current keeps moving whether the crossing is rough or calm. On a calm Drake day, when the surface is smoother, and people call it the Drake Lake, the current is still there. The Great Ocean River has not gone to sleep. It is simply not announcing itself through a dramatic surface. This is useful to remember. The visible sea is only part of the story. A calm surface can sit above enormous movement. A rough surface can be caused by winds acting on water that already has its own direction and flow. The Drake Passage is never truly empty, even when it looks still. As the ship continues south, it crosses over this moving boundary between the more familiar ocean world and the colder Antarctic one. The current helps make that boundary real. It helps explain why the air changes, why the wildlife changes, why the water feels different, and why Antarctica seems so separated from the rest of the planet. The farther south the ship moves, the more the current's role becomes part of the larger approach. Antarctica is not just remote because it is distant. It is remote because the ocean around it is powerful, cold, and constantly in motion. There is something reassuring about that, in a strange way. The Drake Passage may be dangerous, but it is not senseless. Its roughness has causes. Its power has structure. The current beneath it belongs to a global system that can be studied and understood, even if not fully controlled. The ocean is doing what the ocean does. It is moving under wind, around land, over seafloor, through temperature differences, and across the long path around Antarctica. For a traveller, the current may be part of the discomfort. For the planet, it is part of the machinery that keeps climate and ocean circulation connected. For wildlife, it helps shape a productive cold water world. For scientists, it is a subject of constant measurement and concern. For the sleeping listener, perhaps it can be held more simply for now. A great ring of water circling the bottom of Earth, passing through the Drake Passage, carrying cold, nutrients, energy, and history with it. And above that great moving river, the surface begins to rise and fall. Wind presses down. Swell arrives from far away. Currents and waves meet. The ship responds with a slow lift, a roll, a pause, and then another lift. This is where the famous crossing becomes personal, where global circulation turns into footsteps in a corridor, cups sliding on tables, and the old question every passenger quietly asks sooner or later: how much movement can one stretch of water possibly have? How much movement can one stretch of water possibly have? In the Drake Passage, the answer is usually more than a first-time passenger expected, and sometimes more than they would have preferred to learn about through direct personal experience. This is where the famous Drake Shake enters the story. The name sounds almost playful. It could be a milkshake, a dance move, or something invented by a cheerful activity coordinator on a ship with too much confidence. But anyone who's crossed the passage in rough conditions knows that the phrase has a very practical meaning. It describes the version of the crossing where the sea rises, the ship rolls, drawers slide open, chairs become suspicious, and passengers begin to walk in the slow, careful style of people carrying invisible trays of soup. The Drake Shake is not one single condition. It is a mix of waves, swell, wind, current, and ship motion. Sometimes the movement is a steady roll from side to side. Sometimes it's a pitch, where the bow rises and drops as the ship moves over oncoming seas. Sometimes it is a more complicated combination, with the vessel lifting, leaning, correcting, and then doing something new just as everyone has adjusted to the old pattern. This is why walking on a ship in rough water can feel like negotiating with a floor that keeps changing its mind. The waves in the Drake Passage are not famous by accident. As we have already seen, the region has the right ingredients for large seas. Strong winds blow across long distances of open water. Those winds have time to push energy into the surface. There is very little land to interrupt the process. Storm systems can move through the Southern Ocean with room to grow. The Antarctic circumpolar current passes through the passage, and the seafloor below is uneven enough to make the movement more complicated. Put all of that together, and you have a place where the sea can build with impressive confidence. A wave begins in a surprisingly simple way. Wind moves across the surface of the water. Friction transfers energy from air into sea. Tiny ripples form. If the wind continues, those ripples become larger waves. The stronger the wind, the longer it blows, and the greater the distance over which it blows, the bigger the waves can become. This distance is called fetch, and the Southern Ocean is famous for giving wind a very long fetch to work with. The ocean there does not keep politely bumping into continents. It stretches around Antarctica in a huge open belt, giving storms space to turn moving air into moving water. That is why the Drake Passage can feel so active even before the worst weather arrives. The waves under a ship may not have been born nearby. They may have travelled from a storm far away, crossing hundreds or even thousands of kilometres before reaching the passage. These longer travelling waves are called swell. Swell is different from local chop. Local chop can be short, steep and messy, especially when wind is blowing hard in the same area. Swell can be longer, heavier, and more organised. It may arrive with a slow, powerful rhythm that makes a ship rise and fall in a way that seems almost calm from a distance until you try to pour water into a glass. This is one of the little tricks of the sea. It can look graceful and still be very difficult to stand in. A long swell moving under a ship may not break dramatically. It may not throw white water everywhere. It may simply lift the entire vessel, pause, and lower it again. Then another comes, and another. From a window, it may seem almost orderly. Inside your body, however, your balance system is taking notes, raising concerns, and eventually sending a strongly worded message to your stomach. Seasickness is not weakness. This is worth saying plainly. It is not a failure of character, courage, or enthusiasm for Antarctica. It is your brain trying to make sense of conflicting information. Your inner ear detects motion. Your eyes may be looking at a cabin wall, a book, a phone screen, or a dining table that appears still relative to you. Your muscles and joints feel the floor moving under you. The brain receives messages that do not agree, and for many people, that mismatch produces nausea, dizziness, sweating, tiredness, headache, or the sudden desire to be left alone in a horizontal position. It's a very old problem in a very modern setting. The human body evolved for walking, running, sitting, climbing, and lying down on ground that generally does not lift 6 meters and roll sideways. A ship is safe, engineered, and controlled, but the body does not always appreciate the distinction. Your inner ear is not reading the brochure. It is reporting movement. Your eyes may insist that the room is stable. Your brain tries to compare these reports, and the result may be the deeply unfair feeling that your own body has joined the ocean's side. This is why people are often told to look at the horizon. The horizon gives the eyes a stable reference point that better matches the motion sensed by the inner ear. Fresh air may help. Staying hydrated may help. Eating small, plain foods may help. Medication or patches may help many travellers. Lying down can help because it reduces the need to constantly balance. These Practical details may not sound dramatic, but during a rough Drake crossing, practical details become very important. A cracker can feel like a life plan. A well-timed ginger sweet can seem like advanced technology. A secure handrail becomes a trusted friend. Ships that cross the Drake Passage are designed with rough seas in mind. Modern expedition vessels are far more capable than the old ships that rounded Cape Horn under sail. They have strong hulls, navigation equipment, communication systems, weather routing, trained crews, and often stabilizing systems that reduce rolling. But no ship can make the ocean stop moving. Technology can manage risk and improve comfort, but it cannot cancel the Southern Ocean. That is part of the experience. The vessel is not pretending the Drake is easy. It is built to cross it with planning and respect. For passengers, the first signs of the Drake shake often appear in small ways. A cup slides a little. A door swings unless latched. A person walking down a corridor reaches out to touch the wall without thinking. The ship rises, pauses, and settles. The movement becomes part of the room. Conversations slow slightly as people concentrate on balance. Someone laughs too brightly after nearly missing a step. Someone else announces that they feel completely fine, which may or may not remain true after lunch. Then the body begins to sort people into groups. There are the fortunate ones who do not get seasick and are sometimes wise enough not to mention this too often. There are the mildly affected, who become quiet, careful, and loyal to plain bread. There are the determined observers who insist on staying on deck because the air helps. There are the cabin dwellers who have made peace with the ceiling and prefer not to receive updates. And there are the experienced travellers who took medication early, ate sensibly, and move around the ship with the calm expression of people who have learned not to challenge the Drake unnecessarily. Meals during a rough crossing can become memorable. Dining rooms on expedition ships are built for movement, but food still has opinions. Soup is an ambitious choice. Salad leaves may travel. Bread rolls can migrate across a plate with surprising purpose. Staff and crew, who have seen all of this many times before, move with skill and good humour. They place items carefully, steady trays, and somehow make normal service continue, while the room itself is gently disagreeing with the concept of level. It is one of the many reasons crew members deserve respect. They do not just work at sea, they work at sea while carrying hot drinks. The sound of waves during the Drake shake is part of the memory. A ship in rough water is not silent. There is the low impact of the hull meeting swell. There is the rush of water along the sides. There may be creaks, thuds, rattles, and the occasional mysterious noise that everyone decides not to investigate too emotionally. At night, these sounds seem larger. The cabin is dark. The bed moves. The ship lifts. Something small shifts in a drawer. Outside, the sea continues without needing sleep. It can be comforting if you trust the ship, and unsettling if your imagination has been allowed too much caffeine. The motion itself can become hypnotic after a while. At first, every roll is noticed, every lift is measured, every sound is interpreted, but the body and mind can adjust. The ship's movement becomes background. People learn to time their steps. They stand with a wider stance. They keep one hand free. They choose seats carefully. They discover that turning quickly is a poor idea. The Drake shake becomes not exactly normal, but familiar. The sea has not grown calmer. The passenger has grown slightly more experienced. That familiarity has always been part of life at sea. Sailors learn to read motion the way land people read roads. A certain swell direction, a certain wind sound, a certain change in pressure, all carried meaning. A wave was not just a wave, it was information. It told you something about distant weather, current, depth, and what might be coming. In the Drake Passage, that knowledge mattered because conditions could become dangerous quickly. To understand waves was to understand risk. To misread them could cost lives. The most dangerous waves are not always the largest ones seen from a distance. Steepness matters. Direction matters. Timing matters. A long swell may be uncomfortable, but manageable. Short, steep breaking seas can be more hazardous. Cross seas, where waves come from different directions, can create confused motion. When wind, swell, and current interact, the surface can become irregular. Ships are designed to handle rough water, but captains still make careful choices about angle, speed, and route. The aim is to reduce strain on the vessel and keep everyone safe. In rough conditions, comfort may temporarily become a secondary ambition, somewhere below safety and above whether anyone feels like attending the afternoon lecture. The Drake Shake has become part of Antarctic travel culture because it is one of the few parts of the journey that almost everyone talks about. Before departure, people ask, "How rough will it be?" After arrival, they ask, "How was your crossing?" The answer becomes a small badge of experience. Some say it was calm, almost disappointing, though usually with gratitude underneath. Some say it was rough but manageable. Some describe a rolling 2-day blur of sleep, crackers, and quiet self-reflection. A few become storytellers immediately, giving wave heights, angles, and personal heroics, with the confidence of someone who survived a dining room incident involving a sliding dessert. This storytelling is not new. Dangerous waters always create stories. Sailors once carried tales of Cape Horn and the Southern Ocean from port to port. Modern travellers carry videos, photos, and slightly exaggerated hand gestures. The tools have changed, but the impulse is the same. When humans pass through a place that makes them feel small, they return with descriptions. They want to explain what it felt like. They want others to understand the size of the water, the force of the movement, the odd humour of trying to brush teeth while the bathroom changes direction. The phrase Drake Shake also has a companion, the Drake Lake. This is the calmer version of the passage. When the sea settles, the ship moves gently, and passengers are treated to a crossing that feels almost suspiciously kind. The Drake Lake can happen, and many travellers hope for it. On those days, the surface may still roll, but it does not dominate the experience. People attend lectures, eat properly, take photographs, and wonder whether the passage's reputation has been overdone. The sensible answer is no. A quiet dog is still a dog. A calm drake is still the drake. It is simply in a better mood. The existence of both versions is important. The Drake Passage is not a machine that produces identical crossings. It is a living weather and ocean system. One ship may cross in rough conditions, while another crosses days later in relative calm. Seasons, pressure systems, wind direction, swell patterns, and route choices all influence the experience. This unpredictability is one reason the crossing remains so famous. People do not only fear the Drake Shake, they wonder which drake they will meet. For some, the roughness becomes meaningful after it is over. During the movement, it may feel mostly inconvenient. Later, it becomes part of the memory of reaching Antarctica. The discomfort draws a line between ordinary travel and expedition travel. Airports and hotels can make the world feel strangely easy to move through. The Drake Passage does the opposite. It reminds travellers that Antarctica is not just another destination. It is separated by a serious ocean. The crossing gives the arrival a sense of distance that a flight cannot provide in the same way. There are flights to parts of the Antarctic region, and for some travellers they make sense. But crossing by ship gives a gradual approach. South America fades behind. Open water takes over. Birds appear. The air changes. The sea has time to make itself known. Then, after a day or two, land appears again, but it is not the same kind of land. Ice, rock, snow, and cold mountains come into view. The Drake Passage becomes the transition. Rough or calm, it marks the crossing from one world into another. That is why people often speak of it with both dread and affection. The Drake Shake may make passengers miserable for a while, but it also becomes part of the shared experience. On board, people compare symptoms, strategies, and small victories. Someone discovers that they can still eat breakfast. Someone else discovers that they cannot. People laugh carefully because laughing too hard in rough seas can be a tactical mistake. A strange community forms around the simple fact that everyone is moving together through the same restless water. The ship itself becomes a little world. Outside is the Southern Ocean. Inside are warm lights, lectures, meals, cabins, charts, announcements, and people learning the rhythm of the vessel. During a rough crossing, ordinary spaces become more important. A lounge chair near a window becomes a refuge. A hallway becomes a route to be planned. A staircase becomes an event. The bed becomes the most reliable piece of furniture in the universe. The ship is not just transportation. It is shelter, workplace, classroom, dining room, and moving observation platform. For all the discomfort, there can be beauty in a rough Drake crossing. The sea has scale. Waves lift and pass with heavy strength. Foam streaks across dark water. Spray blows sideways. Birds appear in the air beyond the rail, steady and capable. Clouds move low and fast. The horizon changes shape. The ship's bow cuts into the swell and rises again. It is not comfortable beauty, perhaps. It is not the kind that asks you to sit with a picnic blanket. It is the kind that asks you to hold the rail and pay attention. That attention is part of why the Drake stays in memory. Modern life often keeps the physical world at a distance. Temperature is controlled, floors are flat, roads are engineered, schedules are planned. The Drake Passage removes some of that control. It brings the body back into direct contact with motion, weather, and scale. You cannot scroll past it. You cannot hurry it. You cannot persuade it with good manners. You cross at the speed the ship can safely manage, in the conditions the sea provides. And still, the crossing ends. This is a comforting fact for anyone listening who imagines being trapped forever in a rolling corridor. The Drake Shake may feel long, especially for the seasick, but it is a passage, not a permanent address. Eventually the swell changes. The ship moves farther south. The first signs of Antarctica approach. Birds may become more numerous. The air may feel different. People who spent the previous day horizontal begin to reappear, pale but hopeful, like houseplants after a difficult winter. By then, the Drake has done its work. It has introduced the traveller to the scale of the Southern Ocean. It has made the journey feel real. It has turned maps into movement. It has shown why sailors respected these waters long before modern tourism gave the experience a catchy name. The waves and swells are not just obstacles. They are the visible surface of wind belts, currents, geography and history working together. And history is waiting just behind those waves. Long before expedition ships carried passengers toward penguins and icebergs, other vessels came through these waters under very different conditions. Their crews did not have stabilizers, satellite forecasts or comfortable cabins waiting below. They had sails, rope, wood, cold hands, hard work, and the old fear of being caught near Cape Horn with too much weather and too little room. The Drake Shake may be a modern phrase, but the water behind it has been testing sailors for centuries. The Drake Shake may be a modern phrase, but the water behind it has been testing sailors for centuries. Long before warm expedition ships carried travellers toward penguins, icebergs, lectures, and heated dining rooms, the southern end of South America was a place sailors spoke about with caution. Not because it looked frightening on a map, though it certainly had a severe shape to it, but because the real test began when the land fell away and the sea took over. Cape Horn and the waters nearby were not just another turn in a route. They were a hard corner of the world, a place where a ship could meet wind, current, fog, cold, waves and exhaustion all at once. For centuries the problem was simple to describe and difficult to survive. Ships needed to move between the Atlantic and Pacific Oceans. Before the Panama Canal, there was no easy shortcut through the Americas. A vessel travelling from one side to the other often had to go far south, down toward the rough latitudes below South America, around Cape Horn, and then back north again. It was a huge detour, but it was also the available road. A road made of water, wind, and bad timing. it is worth remembering how different that world was. Today, a captain can study satellite forecasts, weather models, radar, engine, performance, ice reports, and communication updates. A modern ship crossing the Drake Passage may still move heavily, but it does so with a great deal of planning and technology behind it. In the age of sail, a ship was a wooden world with cloth wings, rope, human muscle, and judgment. The crew could not check a forecast app and decide that next Tuesday looked friendlier. They read the sky, the sea, the pressure, the birds, the temperature, and the behaviour of the ship itself. Sometimes they were right. Sometimes the Southern Ocean corrected them. Sailing ships depended on wind, which sounds romantic until the wind is too strong, from the wrong direction, and has been shouting at you for 3 days. A sailing vessel could not simply point where it wanted to go and proceed. It had to work with the wind, tack against it, run before it, shorten sail when needed, and survive when the weather became too much. Around Cape Horn, this could mean brutal labour. Men climbing into rigging stiff with ice, wet decks, heavy lines, torn canvas, cold hands that could barely close. Watches kept through darkness and spray. Orders shouted into winds that did not care to listen. The old fear of these waters was not imaginary. It came from repeated experience. Ships were damaged. Ships were delayed. Ships were lost. Crews were injured, exhausted, frozen, and sometimes killed. The sea around Cape Horn became famous because it combined several hazards in one place. Strong westerly winds came around the Southern Ocean, with little land to slow them. Waves built over long open distances. Currents added their own movement. The weather changed quickly. Navigation was difficult. The land itself, when close, could be dangerous because rocky coasts and poor visibility left little room for mistakes. In many sea stories, land is safety. It is the thing sailors hope to see after weeks offshore. Near Cape Horn, land could also be a threat. A ship too close to shore in bad weather might be pushed toward rocks. A lee shore, where the wind drives a vessel toward land, was a terrifying prospect. Out in open water, a ship could at least run, turn, and use sea room. Near a dangerous coast, options narrowed. Cape Horn did not offer the soft welcome of a harbour. It stood at the edge of some of the roughest navigable waters in the world, and sailors knew it. The Drake Passage itself carries a name connected with Sir Francis Drake, the English sailor and privateer whose 16th century voyage helped put the region into English maritime imagination. But the water was known in other traditions too. Spanish sources have used the name Mar de Hoces, linked to Francisco de Hoces, who's associated with being driven south of the Strait of Magellan in 1525. This is one of those historical details that reminds us how naming places often depends on who is telling the story. The sea existed long before any European chart marked it, and people gave it names according to voyages, languages, claims, fears, and memories. Then came another important moment in 1616, when Willem Schouten and Jacob Lemaire sailed around the southern tip of South America and helped establish the route around Cape Horn. The name Cape Horn comes from the Dutch city of Hoorn, and it entered maritime history with a force far larger than the little word itself. After that, Cape Horn became not just a geographical point but a test. To round the Horn meant something. It meant a crew had gone down into the latitudes of hard wind and high sea and come back with the ship still under them. There was pride in that. Sailors who had rounded Cape Horn were often treated as having passed through one of the world's great trials at sea. The achievement carried weight because everyone in that world understood what it demanded. It was not a comfortable badge. It was earned in cold spray, wet clothing, torn hands, fear, skill, and patience. A person did not need to exaggerate much. The route provided plenty of material on its own. Cargo ships, clippers, naval vessels, whalers, sealers, and explorers all had reasons to move through or near these southern waters. Some were chasing trade, some were chasing profit, some were chasing maps, Some were chasing whales or seals in chapters of human history that were profitable for people and devastating for animals. The Southern Ocean routes became part of a global system of commerce and empire, linking ports and markets over enormous distances. The Drake, Passage and Cape Horn were not remote curiosities. They were part of the machinery of the world before modern canals and engines changed the routes. The great sailing ships of the 19th century had to balance speed with survival. A fast route mattered. Cargo had value. Schedules mattered, even then, although the ocean often treated schedules as suggestions written on damp paper. The southern route could be useful because the strong westerlies helped ships moving eastward. A vessel travelling with the wind could cover long distances quickly. But trying to move against those winds, especially from east to west around Cape Horn, could become a long struggle. Ships might spend weeks fighting their way through storms, losing progress, gaining a little, losing it again, while the crew endured cold and fatigue. There are accounts of ships being driven back again and again while trying to around Cape Horn. Imagine working for days to gain ground, only to have weather shove you away from it. Imagine the same grey sea, the same hard wind, the same wet deck, and the same knowledge that the ship had still not passed the dangerous corner. This kind of delay was not merely annoying. It consumed food, water, strength, and morale. A voyage could become a battle of endurance, and the enemy was not a single storm, but the whole pattern of the place. The fear sailors carried was practical. It was not fear of a legend in the water or a sea monster below the hull. It was fear of broken masts, ripped sails, flooded decks, freezing weather, poor visibility, disease, injury, and the slow wearing down of a crew. It was fear of being caught in conditions too strong for the ship. Fear of running out of sea room. Fear of a man being swept overboard, which in those waters often meant there was little hope. Fear of the ship itself beginning to fail under repeated strain. Wooden ships were strong, but they were not invincible. Everything on board was under stress in heavy weather. Masts, rigging, planks, pumps, cargo, hatches, crew. Water coming aboard had to be managed. Sails had to be reduced before they tore apart or overpowered the vessel. Men had to go aloft in conditions most people today would avoid even from a safe balcony. Mistaken judgment could be costly. Waiting too long to shorten sail might damage the ship. Shortening too much might leave the vessel without enough control. Every decision happened in cold, noise, darkness, and motion. That is one of the hard things about maritime history. From a distance it can become picturesque. Tall ships at sunset, white sails, brave crews, a painted horizon. But real working ships were often filthy, cramped, dangerous, and exhausting. Around Cape Horn, beauty did not remove hardship. A sunset over the Southern Ocean may have been magnificent, but it did not dry anyone's clothes or make the rigging less icy. The romance was mostly added later by people not currently trying to keep a ship alive in a gale. The crew lived close to danger for long periods. Sleep was interrupted by watches. Food could be poor. Fresh water was limited. Illness could spread. The cold worked into clothing and hands. In rough weather, even simple jobs became difficult. Cooking became a challenge. Eating became a challenge. Moving across deck became a challenge. Resting became a challenge because the ship never stopped moving. The Drake Shake, as modern passengers call it, was not a temporary travel inconvenience for old sailors. It was part of daily labour, sometimes for weeks. And yet, sailors kept going. That may be the most human part of the story. Fear did not stop the routes because the world demanded movement. Trade demanded movement. Governments demanded movement. Exploration demanded movement. Profit demanded movement. Curiosity demanded movement. People have always crossed dangerous places when the reason seemed strong enough, or when the choice was not really theirs to make. The Drake Passage became feared not because it was avoided completely, but because it had to be faced. There is another kind of fear in these waters too, one connected with uncertainty. A storm at sea is frightening because it reduces the future to the next few actions. Secure that line, turn the ship, pump that water, keep watch, hold course, stay alive. But the larger uncertainty can be worse. How long will this last? Is the weather worsening? Is the ship still sound? Has the current pushed us closer to danger? Will the wind shift before morning? Without modern forecasting, sailors often had to live inside questions that could not be answered until the sea answered them. That is why experience mattered so much. A skilled captain and crew could not control the Drake Passage, but they could read it better. They knew when to press on and when to reduce sail. They knew which changes in cloud, wind, swell and pressure meant trouble. They knew how to keep order when fear moved through the crew. At sea, fear could not be allowed to run the ship. It had to be acknowledged, managed and put to work as caution. Panic wastes energy. Respect saves it. Modern ships still operate on that principle, even with better tools. Respect the passage, watch the weather, secure the vessel, prepare passengers, adjust plans. Do not assume the sea will cooperate simply because the itinerary is printed. The difference is that modern vessels have stronger materials, engines, communications, navigation systems, and far more reliable information. The old sailors had skill too, but their margin for error was smaller. Their ships could be trapped by wind. Their knowledge of what lay ahead was limited. Their rescue options were often none. The opening of the Panama Canal in 1914 changed the importance of the Cape Horn route for global shipping. Suddenly, many vessels no longer needed to go all the way around the southern end of South America to move between the Atlantic and Pacific. The canal shortened routes dramatically and made the old southern passage less central for trade. This did not make Cape Horn or the Drake Passage less dangerous. It simply meant fewer commercial ships needed to face them as part of ordinary long-distance routes. That change must have felt enormous. A place that had been a major test for global shipping became, in some ways, avoidable. The world had cut a door through the middle of the Americas. Ships could pass through locks and channels instead of fighting the far southern ocean. For sailors who knew Cape Horn, the difference was not small. It was the difference between weeks of hazardous southern sailing and a controlled passage through a human-made route. The ocean had not become gentler. Humans had found another way around part of its difficulty. Still, the old reputation remained. Cape Horn continued to hold symbolic power. Sailors still rounded it. Racing yachts still treat it as one of the great marks of ocean sailing. Adventurers still speak of it with respect. The name still means hard water, strong wind, and a kind of seamanship that cannot be faked. Even if world trade moved away from the route, the story stayed. The Drake Passage also became important in another kind of history, Antarctic exploration. Explorers heading south had to cross these waters or nearby southern routes to reach the frozen continent and surrounding islands. Their goals were different from traders, but the sea did not soften itself for science or glory. Ships carried expeditions toward cold places where maps were incomplete, and survival depended on planning, luck, and endurance. The crossing was the first reminder that Antarctica was not simply distant. It was guarded by weather and ocean. The age of Antarctic exploration brought its own stories of hardship. Names like Shackleton, Scott, Amundsen, and others are often associated with ice, sledges, and polar camps. But every Antarctic expedition also depended on ships. Before anyone could struggle over ice, a vessel had to reach the region. Men, dogs, food, coal, scientific instruments, clothing, and hopes all had to be carried through southern seas. The ship was the lifeline. Damage or delay at sea could shape the entire expedition before anyone set foot on the ice. The fear of the Drake Passage was therefore not only fear during the crossing, it was fear of what a bad crossing could do to everything that followed. A damaged ship might mean lost supplies. A delayed arrival might mean missed seasonal windows. A crew exhausted before landing might be less prepared. A vessel trapped or wrecked could turn an expedition into a disaster. In polar travel, timing matters. The sea, the ice, and the weather are all connected. The Drake was part of that chain. For modern Antarctic tourism, the fear has changed shape. It is usually no longer the fear of shipwreck in the old sense. It is more often fear of discomfort, rough motion, cancelled landings, delay, or the unknown. Passengers wonder whether they will be seasick. They watch videos, they read accounts, they compare the Drake Shake and the Drake Lake. They pack medication with the seriousness of people preparing for a personal duel with gravity. The danger is managed far more carefully now, but the reputation still enters the mind before departure. That mental anticipation is powerful. Some travellers begin crossing the Drake before they ever leave port, simply by imagining it. They read about waves, they hear stories, they watch clips of ships moving through heavy seas. By the time the vessel departs, the passage already has a place in their thoughts. This is part of how fear works. It lives partly in facts and partly in expectation. The Drake has enough facts to deserve caution, and enough stories to keep imagination busy. There is a long tradition of sailors using humour to live with fear. This continues today. People joke about the Drake Shake because humour gives the body a little room to breathe. A rough crossing becomes a shared story. A sliding plate becomes a harmless adventure. A difficult night becomes something to laugh about after it ends. This does not mean the fear is false. It means people have always needed ways to carry it. Old sailors had songs, sayings, rituals, and hard-won habits. Modern passengers have group chats, seasickness tablets, and nervous jokes over breakfast. The tools differ, but the need is similar. When the sea is bigger than you are, laughter can help. Not because it changes the waves, but because it changes the person facing them. The long history of fear around the Drake Passage is also a history of respect earned by repetition. One storm might create a story. Centuries of storms create a reputation. Sailors learned that these waters required preparation. Ships were built, routed and handled with the southern latitudes in mind. Captains planned around seasons and weather when they could. Crews understood that rounding Cape Horn was not ordinary work. It demanded attention. Fear, in the best sense, is attention. It says, do not be careless here. Do not assume. Do not treat this water as a flat road. That kind of fear has saved lives. The problem is not fear itself, but fear without knowledge. The old sailors who survived learned to combine fear with skill. Modern crews do the same, though with better information. The Drake Passage is not conquered by pretending it is harmless. It is crossed by understanding that it is not. There is a quiet dignity in that. Human beings are not the strongest things in the Southern Ocean. We're not built like albatrosses, whales, or ice. We need vessels, clothing, instruments, fuel, charts, and plans. We need each other. A ship is one of the clearest examples of human cooperation. It works because many people understand their roles, maintain systems, respond to changes, and trust shared knowledge. In the Drake Passage, that cooperation matters. It always has. The old wooden ships and modern expedition vessels are very different, but they share one basic truth. Neither crosses alone. A ship is a community moving through risk. Some members steer, some maintain engines or sails, some cook, some clean, some navigate, some care for passengers, some study the weather, some stand watch while others sleep. The sea outside may be indifferent, but the human response inside the vessel is organised and deeply social. That has been true from the age of sail to the present. This is one reason ship stories stay with us. They are not only about water, they are about people under pressure. A hard sea reveals habits, leadership, patience, fear, kindness, and skill. In rough weather, small actions matter. Securing a door, helping someone down a passageway, checking equipment, making soup that does not become airborne, keeping calm in front of passengers. These details may not make grand history, but they are how crossings are actually lived. The Drake Passage has seen many kinds of ships: explorers' vessels, sealers, whalers, merchant ships, naval ships, scientific research vessels, ice-strengthened expedition ships, yachts. Each brought a different purpose, but all entered the same region of wind and water. Some came for profit, some for discovery, some for science, some for adventure. The passage did not adjust its behaviour according to motive. A noble purpose does not flatten waves. A commercial purpose does not thicken the hull by magic. The sea treats all vessels according to physics. That is one of the reasons fear around the Drake feels so old. It comes from a place where human reasons meet non-human forces. A sailor may have a contract, a captain may have orders, a scientist may have research goals, and a tourist may have a lifelong dream, but the wind is still wind. The current is still current. The wave is still wave. The ship must answer all of them. As the modern vessel continues south through the passage, it carries this history even if no one speaks of it at length. The passengers may be thinking about Antarctica ahead, but beneath the present crossing lies a long memory of ships and sailors who faced these waters with fewer comforts and greater risks. Every safe modern crossing rests on centuries of accumulated knowledge, mistakes, inventions, losses and improvements. The route has been made safer not because the Drake became kinder, but because people learned more. And sometimes, after all that history, after all those warnings, after all the stories of Cape Horn and the Southern Ocean, the Drake Passage does something almost rude in its simplicity. It calms down, the wind eases, the swell lengthens, the ship moves gently, people come outside, the horizon opens, the feared water becomes smooth enough that travellers begin to wonder whether the old sailors would believe them. This gentler face has its own name now, and it is the one every seasick passenger secretly hopes to meet. And sometimes, after all that history, after all those warnings, after all the stories of Cape Horn and the Southern Ocean, the Drake Passage does something almost rude in its simplicity. It calms down. The wind eases, the swell lengthens, the ship moves gently, people come outside, the horizon opens, the feared water becomes smooth enough that travellers begin to wonder whether the old sailors would believe them. This gentler face has its own name now, and it is the one every seasick passenger secretly hopes to meet. The Drake Lake. It sounds harmless, doesn't it? Almost pleasant. The kind of name you might give to a peaceful holiday spot with wooden cabins, a small pier, and someone in the distance trying to start a barbecue with far too much confidence. But this lake is not a lake at all. It is still the Drake Passage. It is still the same stretch of water between South America and Antarctica. It still lies beneath the same southern wind belts, above the same powerful current, and within the same wide-open ocean system that has unsettled ships for centuries. The only difference is that, for a while, the ingredients have lined up in a kinder way. The wind has dropped, or shifted. The swell has spread out. A storm has moved away. A low-pressure system has chosen another route. The sea, which yesterday may have been busy proving a point, now seems content to roll in long, gentle breaths. Passengers who prepared themselves for 2 days of heroic suffering find themselves walking upright, eating breakfast, and looking almost disappointed that their dramatic survival story has become mostly about croissants and birdwatching. That is the strange comedy of the Drake Lake. People hope for calm water, of course. They hope for easy sleep, steady meals, and the ability to cross a room without developing a new relationship with the wall. But when the crossing is very calm, some of them feel a small sense of having missed the legendary trial. They came ready to meet the monster, and the monster is sitting quietly with its paws folded. It is hard to complain. It is also hard not to feel that the Drake is playing a private joke. A calm crossing does not mean the Drake Passage has lost its power. It means power is not always loud. The same ocean can be dangerous one week and gentle the next. That is not weakness. It is variability. Weather systems move. Winds rise and fall. Swells travel through and fade. Currents continue beneath the surface whether the water above looks rough or smooth. The Drake Lake is not a different place. It is a different mood within the same place. This matters because the reputation of the Drake Passage can become so dramatic that people imagine it as constantly violent. In reality, the passage has a range of conditions. It can be rough, moderate, calm, confusing, grey, bright, windy, quiet, and everything between. A traveller may cross in the Drake Shake on the way south and return through the Drake Lake on the way north. Or the other way around. Or meet something in the middle, a drake that neither shakes nor sleeps but simply rocks along with enough motion to remind everyone where they are. The calm days are important because they show the passage more clearly. In rough weather, attention narrows. People think about balance, nausea, safety, movement, and how far away the next meal is. In calmer weather, the mind has more room. Passengers go on deck and stay there. They watch birds for longer. They notice the texture of the water, the shape of clouds, the temperature of the air, the slow change in light as the ship moves south. They begin to feel the crossing not as a battle, but as a transition. The Drake Lake can make the journey feel spacious. The sea may spread out in wide, low folds. The ship moves steadily, with a gentle rise and fall rather than a heavy roll. The horizon stays where it belongs, which is always a comfort. Cups remain on tables. Books can be read. People attend lectures without staring fixedly at one spot on the wall. The dining room fills again. Conversations become livelier. Someone who spent yesterday pale and silent reappears with the expression of a person who has returned from a private expedition to the underside of a blanket. In this calmer state, the Drake Passage becomes a place to observe rather than endure. The deck turns into a viewing platform. The water stretches in every direction, not empty, but open. Seabirds follow the ship. Albatrosses slide over the air with barely a wing beat. Petrels skim low over the surface. The ship's wake trails behind in a white line that slowly loses itself in the grey-blue water. The air can still be cold, but cold feels different when the wind is not trying to remove your face. People linger outside. Cameras appear. Binoculars are lifted. The crossing begins to feel generous. For many travellers, this is when the Southern Ocean becomes beautiful in a quieter way. Not dramatic, not violent, not showing off, but broad and steady. The calm sea allows scale to settle in. There is no land in sight. There are no buildings, roads, trees, or signs. The ship is a small moving point on a huge surface. This can feel lonely, but it can also feel peaceful. The world is reduced to water, sky, ship, birds, and the distant promise of ice. There are not many places left where the view is so free of human clutter. The Drake Lake gives people enough comfort to notice that. Yet even on calm days, small reminders remain. A gentle swell still passes under the hull. A door may still swing if left open. The ship still has a slight movement that keeps everyone aware they are at sea. Calm in the Drake does not usually mean flat like a pond. It means manageable. It means the movement is soft enough to live with easily. It means breakfast is no longer an engineering challenge. It means the ship has stopped acting like a lesson in humility and has become more like a slow carriage over water. There is a reason sailors never trust calm completely. Calm is welcome, but it is not a contract. Weather can change. A flat sea in the morning does not guarantee a flat sea tomorrow. The Drake Lake is a gift, not a promise. Experienced crews know this. They enjoy the easier conditions, but they keep watching forecasts, pressure, wind, swell, and route. A passenger may relax into the quiet water. The officers on the bridge relax in a different way, if at all. Their calm includes attention. That attention is part of what keeps modern crossings safe. A ship may pass through the Drake Lake smoothly because the crew has chosen a good weather window, adjusted speed, and read the forecasts well. Sometimes nature helps, sometimes planning helps. Usually it is a mixture of both. The sea is not controlled, but it can be understood enough to make wise decisions. Modern navigation is full of small choices that passengers may never notice. A slight change of course, a change in speed, a decision to avoid a developing system, a quiet adjustment that turns a potentially rougher crossing into something more comfortable. This is why the Drake Lake should not be taken as proof that the passage is harmless. It is proof that dangerous places are not dangerous in the same way every moment. A mountain can have a calm morning. A desert can have a cool night. A volcano can be quiet for years. The Southern Ocean can lie smooth under a pale sky. The danger comes from the capacity of the place, not only its condition at one moment. The Drake Passage has the capacity for serious weather, large swells and difficult crossings. On Drake Lake days, that capacity is resting. For the body, the difference can feel enormous. The inner ear settles, the stomach forgives. People sleep more deeply. They move through the ship with less calculation. Stairs become stairs again, instead of small trials of balance and timing. Reading becomes possible. Writing in a notebook becomes possible. Looking at a phone becomes less risky. The human nervous system, which may have been monitoring every movement of the ship, begins to stand down. It is amazing how quickly gratitude can form around a stable cup of tea. The mood on board changes too. During rough weather, a ship can become quiet because many people retreat to cabins. During calm weather, public spaces fill. People watch the sea through large windows. They attend talks about wildlife, geology, ice, and history. They compare expectations with reality. There is often laughter from those who feared the crossing most, and now find themselves almost suspicious of its kindness. A calm Drake creates relief, and relief is one of the easiest emotions to share. That relief can become part of the story travellers tell later. Some will say, "We had the Drake Lake," almost with pride, as if they personally negotiated it. Others will say it with a hint of apology, especially if speaking to someone who had the Drake shake and now appears to be listening with the polite expression of a war veteran hearing about a picnic. The two experiences are different, but both are part of the passage. Neither is the true Drake by itself. The true Drake is the possibility of both. On a calm crossing, the ship has time to become a classroom. The water outside is not only scenery, it is evidence. Guides may explain the Antarctic circumpolar current, the Southern Ocean, seabird flight, whale migration, plankton, krill, ice, and the history of exploration. The passengers listen while the ship moves through the very systems being described. This is one of the pleasures of expedition travel when the sea allows it. The subject is outside the window. The lecture is not separate from the world, it is happening inside it. The Drake Lake also gives wildlife watching a better chance. Rough weather can make it hard to stand outside or use binoculars. Calm conditions bring more people to the decks. Birds become easier to follow. A distant whale blow may be seen more clearly. The surface of the water reveals small changes. A bird's reflection may appear for a moment. The wake becomes a place to watch. Even when wildlife is sparse, the act of looking becomes satisfying. Open ocean rewards patience, though it does not always do so on schedule. Albatrosses remain especially suited to this crossing. Even when the wind eases, they are present in the story of the far south. Their wings carry a sense of distance. They make the open ocean feel inhabited. A calm Drake with albatrosses gliding behind the ship can feel almost like an invitation to slow down. Not to sleep exactly, though some passengers may do plenty of that, but to let the scale of the place become normal for a while. Sea to every side, sky above, cold air, a bird passing without hurry. It is a very different education from being rolled around in a cabin, but it is an education all the same. The water's surface on Drake Lake days can show long patterns, lines of swell. soft patches of reflected light, slight darkening where wind touches one area more than another, foam from the ship's wake, occasional floating ice if the vessel is far enough south and conditions allow. The sea does not become decorative. It remains huge and cold, but it gives the eye more time to rest on details. The grey is not just grey. It has green, blue, silver, and black within it. The sky is not just overcast. It has layers, movement, and distance. This quieter face of the Drake may be less famous, but it may be just as important. If the Drake Shake teaches respect through discomfort, the Drake Lake teaches respect through scale. Rough water says, "You are small." Calm water says the same thing, but more softly. Standing on deck during a calm crossing, with no land in sight and only the ship's steady progress marking time, a person can feel how much of Earth is ocean. Not as a statistic, as a physical fact. There is water all around, and beneath it more depth than the eye can understand. The calm makes that fact easier to receive. There is also a slight strangeness in seeing a feared place behave gently. Human minds like simple categories, dangerous or safe, rough or calm, monster or lake. But the natural world does not always stay in our categories. The Drake Passage is not pretending to be a lake when it calms down. It is simply showing one of its possible states. We are the ones who give it names to make sense of our experience. Drake Shake for the hard crossing, Drake Lake for the easy one. Both names are useful. Both are incomplete. A calm crossing may also sharpen the anticipation of Antarctica. Without the distraction of seasickness or heavy motion, passengers can think more clearly about what lies ahead. The lectures sink in. The maps matter more. The first iceberg becomes an event. The first sight of land becomes something people are fully awake for, rather than something they stagger toward in recovery. The Drake Lake gives travellers a gentler approach, but it does not reduce the feeling of arrival. If anything, the slow calm can build expectation carefully, 1 hour at a time. The ship keeps moving south. The temperature may fall, the light may change. The sea remains kinder than expected. Inside, boots are checked, waterproof trousers located, camera batteries charged, layers organised. People prepare for landings, zodiac rides, and the rules of visiting a fragile environment. The Drake Lake gives them energy for those preparations. No one has to spend the whole crossing negotiating with nausea. The journey becomes less about survival and more about noticing. There is a luxury in noticing. Not luxury in the sense of velvet cushions and tiny desserts with names longer than necessary, but the deeper comfort of having enough calm to pay attention. Rough seas take attention by force. Calm seas allow attention to choose. A passenger can notice how the ship's bow divides the water, how the wake spreads, how the air changes at sunset, how the sea darkens under cloud, how the world feels when land has been absent for a full day. These observations may seem small, but they are often what remain in memory. The Drake Lake can also make the passage feel timeless, in a practical, ordinary way, not mystical, just simple. Days at sea are not structured like days on land. There are meals, talks, briefings, watches, announcements, and rest, but outside the view changes slowly. The ship moves, the water continues, the sky shifts. There is no traffic, no street corner, no familiar shop, no quick errand. The calm sea supports a slower sense of time. It is easy to understand why long ocean crossings have always affected people's minds. The world becomes broad, repetitive, and quiet enough for thoughts to stretch out. For crew members, calm conditions bring work of a different kind. There is always work on a ship. Calm does not mean idle. Equipment is maintained, plans are checked, safety briefings are prepared, routes are monitored, meals are cooked, cabins are cleaned, engines continue, watches continue. A passenger may see peace, but the ship's routine is full of skilled labour. The Drake Lake may make that labour easier, but it does not remove it. The comfort of passengers rests on people working steadily behind the scenes, which is true in many parts of life and especially true at sea. The calm version of the Drake also shows how much modern Antarctic travel depends on timing. Expedition operators plan voyages during the austral summer, when conditions are generally more suitable for travel and landings than in the darker, harsher months. Even then, no month can guarantee calm seas. The Southern Ocean remains changeable. But seasonal planning gives better chances. Ships cross when daylight is longer, temperatures are less severe, and Antarctic access is more practical. The Drake Lake is more likely when weather patterns cooperate, but cooperation is never guaranteed. That uncertainty can make the calm feel special. A gentle crossing is not owed to anyone, it is received. People go outside because they know conditions may not stay this way forever. They take photographs of water that looks almost ordinary, because they understand it is not ordinary at all. It is the Drake Passage being mild. That is worth noticing. And perhaps there is a lesson in that, though not one that needs to be made too grand. A place can be dangerous and gentle. A reputation can be true and still not describe every moment. The ocean can be calm without becoming tame. The Drake Lake does not cancel the Drake Shake, it sits beside it. Together they make the full character of the passage, unpredictable, powerful, sometimes severe, sometimes strangely kind. As the crossing continues, the ship may pass through hours of soft movement. The last traces of worry leave the dining room, people sleep better, the sea stays low, the horizon remains steady. Somewhere ahead, Antarctica is drawing closer. The calm water carries the vessel toward ice, wildlife, and the cold edge of the continent. Beneath the surface, currents still move. Above the surface, birds still search and glide. The passage is gentle for now, but it is not empty. There is a whole living world connected to this water, hidden under the smoothness, moving through the cold, feeding beneath the waves, and waiting to be understood just beyond what the eye can see. There is a whole living world connected to this water, hidden under the smoothness, moving through the cold, feeding beneath the waves, and waiting to be understood just beyond what the eye can see. From the deck of a ship, the Drake Passage can look empty. That is one of its tricks. The surface may be grey, dark blue, green-black, or streaked with white foam, but it rarely looks inviting. It does not look like a garden. It does not look like a forest. It does not look like a place full of life. It looks like weather sitting on top of water. It looks like cold. It looks like a place where a hat could be removed from your head and sent to start a new life somewhere east of the ship. But below that rough surface, and sometimes right at the surface if you know what to look for, the Southern Ocean is active, very active. Not in the loud, obvious way of a rainforest or a coral reef, where colour and movement are packed into every glance. The life here is colder, wider, more seasonal, and often hidden. It depends on timing, currents, light, ice, nutrients, and the short summer window when the far south becomes productive enough to feed some of the largest animals on Earth. The Drake Passage is not separate from that living system. It is one of the routes through which water, nutrients, animals, and energy move. The same wind and currents that make the passage famous for rough seas also help mix and transport what life needs. The water may not seem friendly to us, but it is not empty. It is a working part of the Southern Ocean food web. At the base of that food web are organisms so small they can be easy to forget. Phytoplankton. These are microscopic plant-like organisms that drift in the upper layers of the ocean. They use sunlight to photosynthesize, taking in carbon dioxide and producing oxygen, much like plants on land. They are tiny, but their importance is enormous. Without phytoplankton, the larger animals of the Southern Ocean would have nothing to build from. No krill, no fish feeding on plankton, no penguins chasing prey, no whales arriving to feed after long migrations. The whole system begins with small cells catching light in cold water. The Southern Ocean is not productive everywhere all the time. Light, ice cover, water mixing, and nutrients all matter. During the darker months, sunlight is limited. During the summer, when days are long and the sun returns with enough strength, phytoplankton can bloom in the right conditions. A bloom is not a flower field, though the idea is useful. It is a sudden increase in microscopic life, a growth of tiny organisms in the water when sunlight and nutrients line up. From the ship, the ocean may still look like ordinary cold water. Under a microscope, it can be busy enough to make a traffic roundabout look restful. Nutrients are one reason the Southern Ocean can support so much life. Water movement brings nutrients into the upper layers where phytoplankton can use them. The Antarctic circumpolar current, fronts, eddies, winds, and mixing all help shape where productivity happens. The ocean is not just a flat container, it is layered, moving and constantly rearranging the conditions for life. A patch of water rich in nutrients can become important feeding ground. A small shift in temperature, ice or mixing can change who thrives there. Then come the krill. Antarctic krill are small crustaceans, only a few centimetres long, and yet it is hard to overstate their importance. They are not dramatic to look at in the way whales are dramatic. They do not leap from the water. They do not stand on ice looking like well-dressed birds at a formal event. They are small, shrimp-like animals that gather in large swarms and feed on phytoplankton and algae, including algae associated with sea ice. But because so many animals depend on them, krill are one of the key links in the Antarctic marine food web. Krill turn microscopic plant life into food that larger animals can use. That is their great job. A whale cannot live by gently sipping phytoplankton one cell at a time. It would be there all afternoon and still have no meaningful lunch. Krill solve that problem. They feed on the tiny producers, gather in huge numbers, and become a concentrated food source for animals much larger than themselves. Penguins eat them, seals eat them, fish eat them, squid eat them, seabirds eat them. Baleen whales, including humpbacks and other large whales, can eat enormous amounts of them during feeding season. This gives the Southern Ocean food web a very direct shape in many places. Sunlight feeds phytoplankton. Phytoplankton feed krill. Krill feed almost everyone else, either directly or through fish and squid. That is a simplified version, of course. Nature rarely agrees to be as tidy as a school diagram. There are other zooplankton, other krill species, fish, squid, salps, microbes, and many side routes in the food web. But Antarctic krill remain one of the central players. If the Southern Ocean had a pantry, krill would be one of the main shelves. Though a very cold and fast-moving shelf, sea ice also matters. To someone watching from a distance, ice can look like frozen emptiness, but the underside of sea ice can host algae. Krill, especially young krill, can feed in association with that ice environment. Sea ice can provide food and shelter at important life stages. This connects the health of krill to the seasonal pattern of ice, which then connects krill to climate, temperature, and the changing conditions around Antarctica. A small animal in the water becomes linked to the behaviour of ice across a continent-sized region. This is how the Southern Ocean works. Nothing important stays small for long. The Drake Passage itself is a corridor for seabirds and marine life. Above the surface, albatrosses, petrels, prions, skuas and other birds may be seen using the winds and searching for food. They are not simply decorating the crossing for passengers with cameras. They are working. They follow food, wind, ships and ocean features. Some species spend much of their lives over open water, returning to land only to breed. The empty-looking sea is their world, and they read it with far more skill than we do. An albatross gliding behind a ship can make the Drake Passage feel different. The human body may be busy adjusting to the role, but the bird moves as if the wind has instructions written into it. Long wings hold steady. The body tilts. It climbs, drops, crosses the wake, and disappears behind a swell before rising again. For a passenger, the wind may be uncomfortable. For the bird, the wind is transportation. The same weather that makes a person zip a coat to the nose gives the bird a way to travel vast distances with little effort. Below the seabirds, fish live in waters shaped by cold. Antarctic fish have evolved in unusual conditions. Some species have special adaptations that help them survive near freezing temperatures. Ice fish, for example, are part of the Antarctic story, and some are famous for unusual blood characteristics and cold water adaptations. The details differ by species, but the main idea is simple enough. Life here has had to solve cold in ways that life in warmer seas has not. The Southern Ocean is not a place where ordinary marine animals simply arrive wearing a scarf. They have to be adapted to the cold environment. Squid also play a role, often less visible than penguins and whales, but important in the diet of many predators. Seals, whales, and seabirds may feed on squid depending on region and species. In the open ocean, squid are part of the middle of the food web, moving energy from smaller prey to larger animals. They are not always seen by travellers, but unseen does not mean unimportant. Much of the Southern Ocean food web operates out of easy view, especially from the deck of a ship where the main visible wildlife may be birds, whale blows, or the occasional fin. Then, there are the penguins, the animals many travellers are waiting to meet after crossing the Drake. Penguins are often treated as comic characters because of the way they walk on land, and to be fair, they do make land movement look like a formal event being handled by someone in flippers. But in water, they are fast, skilled hunters. Their bodies are made for swimming. Wings have become flippers. Dense feathers help insulate them. Their shape allows them to move through water with speed and control. On land, they may look slightly overcommitted to a meeting they are late for. Underwater, they are athletes. Penguins feed on krill, fish, and squid, depending on the species and location. Around the Antarctic Peninsula and nearby islands, several penguin species may be found, including gentoo, chinstrap, and Adelie penguins. Their colonies can be noisy, busy, and very direct about smell. That is another practical fact of wildlife. Nature documentaries often leave out scent, probably out of kindness. A penguin colony is full of life, and life, in large numbers, produces strong evidence of digestion. Still, penguin colonies are remarkable. Birds come and go from the sea, feeding themselves and their chicks. They build nests from stones. They argue over territory. They move in lines across snow and rock. They enter the water with purpose and return carrying food in their bodies for young waiting on land. Their lives depend on the ocean's productivity. If the sea does not provide enough food within reach, the colony feels it. The cute surface of penguin life sits on top of a hard practical truth. Survival depends on the timing and availability of prey. Seals are another part of the living world connected to these waters. Different species use the Antarctic and subantarctic marine environment in different ways. Some feed heavily on krill, others eat fish, squid, or even other seals. Leopard seals, for example, have a reputation that is not based on being especially cuddly. They're powerful predators. Crabeater seals, despite the name, do not mainly eat crabs. They feed heavily on krill. This is one of those names that makes you wonder whether someone at the naming desk had a long day. Seals are well suited to cold water. They have thick layers of fat, streamlined bodies, and the ability to dive and hunt beneath the surface. When seen resting on ice, they may appear lazy, like large grey cushions with opinions. But that rest is part of a life that includes cold, diving, hunting, avoiding predators, breeding, and navigating a demanding environment. A seal hauled out on ice is not simply relaxing for our benefit. It is saving energy, digesting food, warming in the air, or avoiding what needs to be avoided in the water. And then, of course, the whales. For many people, whales are the emotional centre of the Southern Ocean. A whale blow on the horizon can change the mood of a whole deck. Conversations stop, binoculars rise, cameras appear from pockets with impressive speed. A dark back rolls at the surface, a fin appears, a tail lifts. Then the whale is gone, leaving only a smooth patch or a fading disturbance where it was. The ocean feels larger after a whale appears, not smaller, because a creature that size can vanish so easily. Many baleen whales travel to the Southern Ocean to feed, taking advantage of the seasonal abundance of krill and other prey. Humpback whales, minke whales, fin whales, blue whales, and others are part of the broader Antarctic marine story, though sightings vary. Baleen whales do not have teeth for chewing prey. They filter food from the water using baleen plates. When feeding on krill, they can take in huge mouthfuls of water and prey, then push the water out while retaining the food. It is efficient, strange, and on the scale of a small living submarine deciding to operate a sieve. Whales also connect the Southern Ocean to faraway places. Some migrate long distances between feeding grounds and breeding areas. A whale seen near Antarctica may have travelled from much warmer waters. Its life does not belong only to one location. It links oceans, seasons, and distant coastlines. This makes the Drake Passage and surrounding Southern Ocean part of a much larger pattern of movement. The water below the ship is not an isolated bowl. It is a route, a feeding zone, a seasonal destination, and a piece of the global ocean. Whales were once hunted heavily in the Southern Ocean, with devastating effects on populations. The history of whaling is a hard part of the Antarctic story. It brought ships, processing stations, profit, and enormous loss. Some whale populations are still recovering from that era. When modern travellers see a whale near Antarctica, they are not just seeing wildlife. They are seeing survival after a period when humans took far too much. The calm excitement of a whale sighting carries that history inside it, whether spoken aloud or not. The Southern Ocean also matters for carbon. Phytoplankton take up carbon dioxide during photosynthesis. Some of that carbon moves through the food web. Some sinks into deeper water through dead organisms, waste, and other particles. Krill contribute to this process through feeding and the production of sinking waste pellets. Whales can also play roles in nutrient cycling through their feeding and waste. The details are complex, but the practical idea is that the living ocean is tied to the movement of carbon. The Southern Ocean is not only feeding animals, it is part of the planet's carbon system. This is where the hidden life beneath the Drake Passage becomes more than wildlife watching. The small organisms and feeding relationships are connected to climate. The Southern Ocean absorbs a significant amount of carbon dioxide from the atmosphere, helping buffer greenhouse gas levels. It also takes up heat. These processes are affected by winds, currents, temperature, sea ice, and biological activity. A plankton bloom is not just lunch for krill, it is also part of a larger exchange between ocean and atmosphere. That does not mean every krill or phytoplankton cell should be burdened with a job title. The ocean is not a corporate office, but the combined effect of these organisms is large. Tiny lives, repeated in huge numbers, influence planetary systems. That is one of the most important lessons of the Southern Ocean. The biggest animals depend on some of the smallest. The climate is influenced by organisms too small to see without tools. A whale's feeding season depends on the timing of microscopic growth. The scale jumps from invisible cells to animals longer than buses, all in one chain. The Drake Passage gives a surface view of that chain, but only a surface view. A traveller may see seabirds and perhaps whales. They may not see krill swarms below, phytoplankton in the water, fish moving under the hull, or squid in deeper layers. The water hides most of its work. This can make the Southern Ocean feel mysterious, but it is not empty mystery. It is a real system with real relationships. The more we learn, the less the rough surface seems like the whole story. The living world here is also vulnerable. Cold-adapted ecosystems can be sensitive to changes in temperature, sea ice, and timing. If sea ice changes, it can affect algae, krill, and the animals that depend on them. If ocean temperatures shift, species distributions can change. If fishing pressure increases in key areas, it can create competition with predators that rely on the same food. The Southern Ocean may look too harsh to be fragile, but harsh places can still be vulnerable. In fact, specialized life can be especially sensitive because it is adapted to particular conditions. This is important to say without turning the quiet journey into a lecture with a clipboard. The Drake Passage is not only dangerous to us, it is also part of a region affected by human activity far beyond the ships that cross it. Climate change, fishing, pollution, and global emissions all reach the Southern Ocean in one way or another. The waters may feel remote, but remote does not mean untouched. The bottom of the world is connected to the rest of the world through atmosphere, ocean circulation, migration, commerce, and carbon. That connection can feel uncomfortable, but it can also make the place more meaningful. A person crossing the Drake is not visiting a separate planet. Antarctica and the Southern Ocean are part of Earth's working system. What happens there matters elsewhere. What happens elsewhere matters there. The current that moves through this Drake connects oceans. The carbon taken up in Southern Ocean waters connects to the air above every continent. The animals that feed there are part of global patterns of migration and conservation. The place is remote in distance, but not in importance. There is also something grounding about knowing how much life continues under rough conditions. While passengers worry about waves, krill feed. While wind blows spray from the surface, phytoplankton drift in the lighted layers when the season allows. While the ship rolls, fish and squid move below. While people brace themselves in corridors, seabirds read the wind outside with perfect economy. While the deck seems cold and empty, the ocean is carrying out an ancient routine of feeding, moving, breeding, dying, sinking, and beginning again. Life in the Drake Passage and Southern Ocean is not soft, but it is persistent. It does not need the surface to be gentle. It does not require the sea to look pleasant. It has adapted to cold water, seasonal light, moving ice, strong winds, and the constant motion of one of the most powerful ocean systems on Earth. This is not a warm, shallow reef with sunlight pouring through clear water. It is a cold, deep, high-latitude ocean. Its life is built for that. And perhaps that is why it feels so impressive once you begin to notice it. The roughness above does not cancel the richness below. It hides it. The furious surface is only the lid. Beneath it there are swarms, dives, migrations, blooms, hunts, and chemical exchanges happening beyond easy sight. The Drake Passage is not just a dangerous crossing, it is a moving part of a living ocean wrapped around Antarctica. The ship continues forward, and the water keeps its secrets unless something breaks the surface. A bird passes, a whale exhales in the distance, a patch of foam spreads behind the stern. Somewhere below, krill may be feeding. Somewhere deeper, fish move through cold darkness. Somewhere ahead, the Antarctic Peninsula waits with its ice, rock, snow, colonies, and feeding grounds. The passage is still the passage, capable of shaking or smoothing itself into a lake, but now it is harder to think of it as empty. It is water full of work, water full of small lives and large ones, water that carries food, carbon, cold, movement, and memory. And as the ship draws nearer to Antarctica, that living system begins to meet the visible world more clearly. Birds in the air, whales at the surface, penguins near the ice, seals resting like heavy commas on floes, and humans watching from the rail, reminded that the dangerous water they crossed is also one of the reasons this frozen world is alive. Reminded that the dangerous water they crossed is also one of the reasons this frozen world is alive. And that is one of the strange things about the Drake Passage. It is easy to describe it by what it does to ships. It rolls them, it delays them, it tests them, it makes passengers walk carefully, sleep deeply, eat cautiously, and develop firm opinions about handrails. It has earned its reputation through wind, current, swell, cold, and centuries of hard travel. But if we only describe the Drake as dangerous, we miss part of the truth. It is not only an obstacle, it is a crossing. It is a border, a route, a mixing place, and a reminder that the ocean is not just space between land, by the time a ship has moved across it, something has changed. Not only the view outside the window, though that change is dramatic enough. South America has disappeared. Antarctica has appeared. The familiar world has been replaced by ice, dark rock, cold air, and animals that seem to belong to an older version of Earth. But the traveller changes too, even in a small way. After the Drake, the planet feels larger. The ocean feels less like a background and more like a force. The word remote becomes physical. It is no longer just a description. It is something measured in waves, hours, weather, and the absence of land. A smooth flight can make distance feel unreal. You sit down in one place, stand up in another, and your body has barely had time to understand the geography. But a sea crossing gives distance back its weight. The Drake Passage does this very well, sometimes too well for anyone's stomach. It makes the route to Antarctica feel earned. Whether the water shakes or lies calm, the crossing teaches scale. It takes time. It takes motion. It takes patience. It asks everyone on board to accept that nature is not arranged for convenience. That may sound inconvenient because it is, but it is also honest. The Drake Passage is a place where several truths meet at once. The atmosphere is restless there because the wind has so little land to slow it. The sea is powerful because the Southern Ocean has a room to build, swell across enormous distances. The current is important because it moves around Antarctica and links the major oceans. The wildlife is rich because cold water, nutrients, sunlight, ice, and seasonal timing support a food web that can feed penguins, seals, birds, fish, krill, and whales. The history is serious because sailors once faced these waters with wooden ships, canvas, rope, and far fewer ways to know what was coming. All of that is happening in one stretch of water. From the outside, the Drake can seem like a single dramatic thing. A rough sea, a dangerous crossing, a famous name. But after looking more closely, it becomes clear that its reputation is built from many layers. Geography, wind, current, waves, weather, history, biology, human fear, human skill, human curiosity. The Drake Passage is not simply misbehaving. It is behaving exactly as a place like that would behave when placed between two continents, under powerful winds, over moving currents, and beside one of the coldest regions on the planet. The old sailors may not have used the same scientific language we use now, but they understood enough in the most direct way possible. They understood the cold in their hands. They understood the pull of wet rope. They understood a sail straining in too much wind. They understood a ship losing progress after days of hard work. They understood the fear of land too close and weather too strong. They understood that Cape Horn and the waters near it required respect. They learned that lesson in the body before it was written in textbooks. Modern travellers understand a gentler version of that lesson. A passenger on an expedition ship is not living the life of a 19th century sailor, and it would be a little dramatic to pretend otherwise. There are warm cabins, trained crews, engines, medical supplies, forecasts, stabilizers, radios, and meals prepared by people who somehow manage to cook while the room itself is moving. But even with all those comforts, the Drake still reaches through. It still makes itself known. It reminds travellers that they are crossing a real ocean, not moving through a controlled display. That reminder can be uncomfortable, but it can also be valuable. We spend so much of modern life smoothing out the rough edges of the world. Floors are flat, lights turn on, roads are marked, rooms are heated, maps update in real time, food arrives wrapped, tracked, and reviewed by strangers. Then a place like the Drake Passage says, very calmly and without asking permission, here is wind, here is water, here is distance, here is movement, and here is what it feels like to be small. Being small is not always a bad feeling. It can be frightening, yes, but it can also be calming. There is relief in remembering that we are not responsible for holding the whole planet together. The current moves without us. The wind circles without us. The waves rise and fall without checking our calendars. Penguins feed, krill swarm, albatrosses glide, whales travel, storms form, ice breaks, and the ocean continues its work whether we understand it or not. We can study it, we can respect it, we can cross it carefully, but we do not command it. And perhaps that is part of why the Drake Passage stays in people's minds. It is not only the roughness, it is the honesty of the place. There are no comfortable illusions at sea for very long. A ship may be warm inside, but outside is the water. A person may have a schedule, but the weather has its own. A traveller may want a calm crossing, but the ocean offers what it offers. You learn to accept conditions, adjust your expectations, and take the next careful step. That is useful knowledge, even away from the sea. Then, when Antarctica appears, the crossing begins to make sense in another way. The continent does not arrive as just another destination. It comes after open water, after wind, after waiting, after that long gap between the known and the frozen. The first sight of land can feel quiet and large. A dark ridge under cloud, snow on rock, a line of ice, a shape that slowly becomes real. People gather near windows and railings, cameras come out, but often there is a pause before the photographs begin. The view needs a moment, the mind needs to catch up. After the Drake, Antarctica feels properly distant. Not unreachable, but protected by distance. The water has done its work, it has separated the everyday world from this colder one. It has slowed the journey enough for arrival to matter. If the crossing was rough, land brings relief. If the crossing was calm, land brings wonder. Either way, the passage has prepared the traveller to pay attention, and attention is one of the best things we can bring to places like this. Attention keeps Antarctica from becoming only a backdrop for photographs. It lets us notice the details, the way penguins move with great seriousness over snow, the way a seal rests on ice as if it has solved the problem of comfort completely, the way a whale's breath hangs in cold air for a few seconds before fading, the way icebergs are not simply white but blue, grey, clear, cracked, ridged, and shaped by water and time, the way sound behaves differently in cold open spaces, the way a ship seems both strong and tiny beside the scale of the land and sea. The Drake Passage helps sharpen that attention, because it makes clear that this region is not casual. It is not easy to reach. It is not separate from the forces that shape it. The wildlife, the ice, the weather, and the ocean all belong to one connected system. The dangerous waters are part of the same story as the living waters. The rough crossing and the feeding whales are not unrelated. The wind that shakes the ship helps move the ocean. The current that complicates the passage helps shape the cold world ahead. The nutrients in the water help feed the small organisms that feed the krill that feed the whales. The system is difficult, but it is not meaningless. As the journey comes to its quieter edge, it is worth returning to the simple human feeling of the crossing. A person stands at a window. The ship moves. The sea stretches out. Perhaps the water is rough, perhaps gentle. A bird follows. A cup waits carefully on a table. Somewhere below, engines keep a steady rhythm. Somewhere above, clouds move east. Somewhere ahead, ice begins to appear. It is not dramatic every second. Much of travel is made of waiting, watching, adjusting, and letting the hours pass. But in those ordinary hours, the scale of the place works on the mind. That is especially true at night. The Drake at night is a different experience. The view outside becomes dark or nearly dark, depending on season and latitude. The ship's lights reflect faintly. The sea is heard more than seen. In a cabin, the motion becomes more noticeable because there is less to look at. The vessel rises and settles. A draw may shift. Water moves along the hull. Someone somewhere closes a door carefully. The whole ship seems to breathe with the swell. In those hours, the passage feels old. Not old in a decorative way. Old because the sea has been doing this long before any of us listen to it. And then morning comes, as it tends to do. Even after long nights at sea, the light returns, people emerge, the coffee machines become important, the day's conditions are discussed with great interest. Those who slept well try not to look too pleased. Those who did not sleep well accept sympathy and toast. Outside, the water continues, the crossing continues. The ship keeps moving across one of the most famous sea passages on Earth, carrying a small human community through a large moving system. Eventually, whether after rough hours or calm ones, the Drake is behind the ship. That is another strange feeling. A place that seems so large while inside it becomes a memory. The body steadies. The handrails are needed less. Meals become easier. The stories begin. People say, "It was not as bad as I expected," or "It was worse than I expected," or "I do not wish to discuss the first night." They compare the crossing with the stories they heard before departure. They give the ocean its score, as if the Drake has performed for them, but really they have passed briefly through its long ongoing life. The passage remains. Another ship will cross, another wind system will move through, another swell will arrive from far away. Another group of passengers will wonder which version they will meet, the Drake Shake or the Drake Lake, the rough lesson or the gentle one. The ocean will not answer early. It rarely does. It waits until the ship is out, until land has faded, until the crossing has truly begun. And this is where the story of the Drake Passage becomes more than a story of danger. Danger is there, and it should not be dismissed. These are serious waters. They deserve planning, caution, skill, and respect. But danger alone is not enough to explain why people remain fascinated by the Drake. We are fascinated because it is a place where the planet is visibly active. Wind, current, weather, wildlife, history, and human vulnerability meet in a way that is hard to ignore. It is also a place of passage in the older sense. You go through it and arrive changed, even if only slightly. You know a little more about the sea. You know a little more about your own body's opinion of motion. You know that Antarctica is not merely far away, but separated by water that has its own power and purpose. You know that the smooth surface of a calm day can hide a current moving around the world. You know that roughness can feed life. You know that fear and wonder can exist in the same view. So as we come to rest here, after wind belts, waves, currents, sailors, calm crossings, hidden food webs, and all the strange movement of the southern sea, let's return for a moment to where we began. Where are you listening from tonight? Are you near an ocean, a river, a quiet street, a warm room, a sleeping house? Is it late where you are, or early, or somewhere in that soft middle of the day when time feels a little loose around the edges? And if you were standing at the rail of a ship crossing the Drake Passage, with cold wind on your face and Antarctica somewhere ahead, what do you think you would remember most? The waves, the birds, the first ice, or the simple fact that you crossed a piece of Earth that still feels larger than anything we can plan? If this slow journey through the world's most restless southern waters brought you a little calm, a little curiosity, or simply kept you company while the evening settled around you, I would be ever so grateful if you gave the video a like, and perhaps subscribe if you would like more quiet journeys through science, nature, history, and the hidden workings of the world. It helps this small corner of calm reach other listeners who might need a peaceful place to learn without hurry. The Drake Passage will keep moving after our story ends. The wind will continue around the southern latitudes. The Antarctic circumpolar current will keep circling the cold continent. Waves will rise, travel, and fade. Krill will feed in cold water. Birds will glide over the swell. Whales will surface, breathe, and sink again. Ships will leave South America and point their bows south, carrying nervous passengers, careful crews, scientific hopes, and dreams of ice. And here, for now, you do not need to cross anything. You do not need to steady yourself against a rolling wall or watch the horizon for balance. You can let the wild water remain far away, doing its work at the bottom of the world. You can let the wind blow there, The current move there, the waves lift and fall there. You are here, in this quieter moment, with the story of the Drake settling behind you like a ship entering calmer water. Sleep well, fellow traveller, wherever you're listening from tonight. May your own seas be gentle, your room be still, and your thoughts drift slowly away from the furious surface down into deep and steady calm.